Hello aspirants, how are you all? Hi Ashwath, how are you? How are you doing? Anybody? Okay, yeah, the channel's a bit low till now, but we are uptight to get more traction, get more people. Trying new things now, about new things. One new series has started. First session was yesterday, right? First session, I hope everybody saw. It was yesterday. Great. Saranya is here. Okay, physics was taken yesterday. I hope you guys liked it. And we are going to continue this for the 2026 aspirants. So stick with us, stay with us, and we'll make sure that you understand everything, you get through your exams, and you be successful. Wish you all the best and wish us as well. Okay, great thing. Namaste, hello, hi everybody. All good? Having fun, right? So what has started? Anybody don't get confused with the one shots that we have taken already. You guys know that we have taken one shots on the same topics and multiple other topics. But there is a difference. There is going to be a good amount of difference, which you'll see in lectures which we are going to take now. We are targeting the exam now. Initially, we were kind of in a hurry to, put as many chapters as we can for 2025 aspirants. But now, a good amount of work has been done for them. Physics, sir is also going to cover up whatever is remaining for class 12. So don't worry about all that. Now what we are going to do, I'll explain, although you must have heard it from Sharad sir yesterday, but yeah, I'll explain one thing again. Now we'll understand and learn everything from scratch first of all, and along with that, conceptually we need to become stronger. See, it's very easy to say that I'm just targeting mains. If you target mains, no, even that won't get cleared. Your target should be understanding all the concepts that you have. Yeah, there is a difference of portions, there is a difference of syllabus in both mains and advanced. We know that. Extra in advance in this chapter. What are the topics which are extra in advance in this chapter? I'll tell you. Straight lines, topics which are not in mains. I'll tell you, family of lines is not in mains. Similarly, circumcenter related questions are not generally there in mains. Angle bisector are not there in mains. Then what else can we think about? Parametric forms are there in mains, but they are more explored in advanced. Okay, that is one thing. There are certain topics, but don't think that we are not going to cover them. We'll cover everything. We'll cover everything, but today, from now onwards, if you stick with me, if you stick with all three of us, now onwards, we'll understand, learn everything from into detail, because it's not about mains or advanced. Be it any of the exam, be it mains or be it advanced, especially advanced, if you really want to aspire for advanced, okay, or get good percentile in mains itself, then you need to understand everything from the core of the subject, from into detail, in depth. Everything should be like that. So let's start without wasting any time. Upcoming sessions are already scheduled. Tomorrow there is going to be chemistry. Yesterday there was physics. Next week, for the same topic, we'll be doing all the PYQs right from 2002 to 2024. We'll cover everything. You must be thinking, sir, that session will go on for 2 days. No, it's not going to be like that. Yeah, it might go on longer, but there is a certain way. We have cracked some methods, or we have cracked some, a good way of doing these PYQs. We are trying to set up the same type of questions or similar type of questions, and we are going to proceed like that. So it's going to be fun as well as interesting, fun, interesting and productive, a lot productive. See, main advantage you get in any topic of JEE is by doing the previous year questions. If you keep on doing the books, you know what books do? I'll tell you what books do. Books will always, keep same type of questions again and again. Same type of questions or similar things again and again. But mains and advanced, especially JEE doesn't do that. JEE might use the same concept, same type, but question will be much different. That's the difference between PYQs and solving the book and the other type of questions. Anyway, Yeah, somebody asked that are we going to do questions too, sir? No. Yeah, questions we'll do. Questions we'll do. Examples we'll do. In fact, by the end, as we reach towards the end of the concepts, we'll also do the variety, the general type that we can expect in mains from this topic. The general type. There are hardly 14-15 types in straight lines. It is obviously straight lines is a vast chapter. You know, from last year's in mains, if we talk about, tangents and normals are excluded. That's why straight lines weightage has increased a lot. Last year 600 questions, but still somewhere around 41 questions were asked in all the sets combined from straight lines itself. Trust me, that much of weightage straight lines is carrying right now, and that is why I bought this topic first. Coordinate geometry, basic knowledge, if you guys have, no, you will be able to understand. Even if you don't have, trust me, today we'll start in such a way that it won't look to you like theory or anything. It'll look we'll understand everything from the start, where it started from. So straight line, as you guys know, that is a part of coordinate geometry. Coordinate geometry, you guys learn about it, but still coordinate geometry, where did coordinate geometry start from? Can anybody tell me? Sir, how did idea of coordinate geometry come? You know who invented coordinate geometry? Anybody in the chat box who can tell me who invented, who first found, or who first wrote about coordinate geometry or defined coordinate geometry? Anybody? No? Oh, don't Google right now. Don't Google. We are so fond of Googling, right? Am I audible? No? Let me check. I'm audible. Okay. René Descartes. René Descartes or René Descartes, you can call it. This was the mathematician who actually came up with the idea of coordinate geometry. But how? How? Before coordinate geometry itself, we had geometry, squares, lines, all these things we knew about. Okay, but still, some idea came up, something came up. For example, let's say, leave the invention. Just think of yourself that you are sitting in a 2D plane, two-dimensional plane. Leave two-dimensional plane also. You are sitting in your room. This is your room, let's say. This is your room. Okay, this is your room, let's say. I'll have to keep a track over comments. Okay. Let's say this is your room. Okay, you are sitting here. So I'll give you a brief idea that first of all, there is arithmetic progression you must have heard about. Algebra was there, a lot of algebra was there, determinants, probability, all these things were before coordinate geometry. Then geometry came. In geometry also, then coordinate geometry came. So it is the application and combination of all these things. Now let's take an example. Let's just think that how we can come across the idea of coordinate geometry. For example, you're sitting in your room. This is your room. Obviously, I am assuming a square or rectangular room only. And let's say you have a car. Okay, I'm very bad at drawing, so please don't mind that. Let's say toy car. In the room, you cannot bring the big car. Okay, toy car, obviously. The toy car, you're a child. Just think of yourself as a child. You have a toy car and you're moving this car. Okay, you're moving this car. Everywhere you're moving this. Everywhere, just like a child does. Okay, that's what you're doing. You're moving this car. So instead of a car, I'm just saying that you're moving a point. Car or point, same thing only, no? So let's say this point is being moved. This point is here, then here, then here, then here, then here. So some pattern is formed. Now, what should come in your mind if you are a mathematics person, or if you are curious person? What will come in your mind? Acha, this point is moving. So what is common about it? If I want that, I want to think about this point. I want to explore about this movement. I want to write something or research something about this movement. And you are a genius person. Okay, think of yourself as a genius person already. Equation and all. Okay, later. Equation, Ashwath, yes, one thing is there, but before that, just simply, I want to observe this point. One thing which you could observe is that this point and this point here, there is some similarity here. Can you see some similarity over here? Okay. No? Some similarity is there, no? If I want, this point is, simply we can say, sir, this point from this wall, if we see from this wall, this is wall 1, let's say, this is wall 2, let's say, okay, from this wall, this point and this point both are at same distance. This you could think of, this everybody could think of, anybody could think of. But still, before this, okay, you might be getting the idea what I'm going to talk about. I'm going to talk about the coordinate axis. Eventually, I'm going to talk about that. Sir, XY, okay, XY. That's how XY came. But before that also, if we go a little bit back, I'll tell you how the idea of entire coordinate geometry was developed. Okay, I'll tell you how the idea of entire coordinate geometry was developed. So basically, it's on Google also. If you'll Google, there are some YouTube videos about it also. The mathematician, the great mathematician, was just looking at 3 points that in the plane, in two-dimensional plane, he just marked 3 points on a piece of paper, two-dimensional plane or a piece of paper. He just randomly marked 3 points. Okay, he marked 3 points, and then he said that, okay, if I'm connecting these 3 points, either I'll get a straight line or I can get a triangle. If all the 3 points should be connected, either I'll get a straight line or I'll get a triangle. Okay, this was the idea. He knew about triangle because geometry was invented before, so triangle he knew. Now what happened after making the triangle, after knowing about the triangle, triangle is being formed. Now what about this triangle? Then after some time he started exploring, looking at the triangle, observing, and he thought, yeah, there must be some points, some special type of points inside the triangle. For example, there can be a point which is equidistant from all the 3 vertices. Okay, the geometry was discovered before, so he knew about medians also. There must be some point which is intersection of all the medians. There must be some point which is, if I inscribe a circle here, then this should be the center of that circle. He actually wanted to know about these points. He knew about triangle, but he did not know about the different points inside the triangle which had something special about them. Something special about them. This was the foundation. This was the foundation idea behind entire coordinate geometry, which we are talking about. He actually, the mathematician actually wanted to explore about the different points inside the triangle which had special properties. You know about these points also. You must be hearing in the previous classes. Orthocenter, circumcenter, incenter. What else is there? Centroid, right? So you know about these points. But how to find these points? That's what the mathematician wanted. That's what we want. After this problem of geometry, coordinate geometry was supposed to be invented. Why I'm talking about all this? Right now don't think that, because many problems which will come in mains and advanced also are supposed to be understood by the general idea of coordinate geometry. We always remember the formulas. We always do a lot of formulas. I'll also give you formulas. Don't worry about that. But before the formulas, try to understand how these formulas are being developed. That's very important. If you do not pay attention on the development of the formulas, then no, it's not going to work. So let's say, just now we talked that, sir, there is something common about these points. What is common, sir? This is some distance is there. Let's say that distance is D, and same distance from wall 1 is here. What is different about these 2 points? Sir, this is at some C1 distance, but this is at some C2 distance. What is common about these 2 points? These 2 points where your car is moving. What is common? Sir, same distance from wall 1, but different distance from wall 2. Getting the idea? So that's how we said that, okay. That's how we said that, okay, this is how we can, somehow mark the address of the points. Every point is going to have a different address, because obviously in a room, if we are moving the car is moving at each and every point, and every point is different. We cannot say this point and this point is same. So how do we define that? By an address. Address, you guys know that address idea came up simply. So instead of doing this, what we did, okay, We have two walls, right? We want two walls. So instead of two walls, we'll make two lines. Okay, we'll make two lines. And these two lines, on these two lines, now we can locate different points. Let's say this is point 1, point 2, point 3. Okay, 3 points. These 3 points. So to solve that problem about the different points inside the triangle, the mathematician came across all this. Okay, I have 3 points. If I want to do anything about this triangle, any point inside this triangle, I need to somehow name these points, locate these points, or write the address for these points. That was the idea. Okay, no problem. 3 points. Now, obviously, I want to name these points. I want to locate these points. How will I locate? Right now, just let's not look at the triangle. Let's just talk about 3 points. So he said, okay, on the wall, there can be different points, no? So what he did, he made 1, 2, 3, 4, 5, 6. Number line also was discovered or was spoken about or actually written about in coordinate geometry only. Numbers were there. Number line came when coordinate geometry came. Okay, so definitely this side also there are going to be some points. So he said -1, -2, -3, -4, -5 like this. Here upside 1, 2, 3, and like he kept on doing this. Minus points over here. Now every point could be located. Every point could be addressed, that this is the address. Okay, not a problem. This is going to be the address, because points were variable. Points were variable. Every point is different. The car movement of the car, which we saw in the starting. Stick with the session if you really want to gain approach in coordinate geometry or first part of coordinate geometry, which is the of highest weightage. Then stick in the session. Session might go long, but in maths class, can become a historian in maths class. No. This is not history. I'm just blah. I'm just making it up. This is not what exactly happened. There are different stories about it. Somebody said that he was looking at a mosquito. Somebody says that he was looking at stars, constellations. Some people, everybody has their own version of the story. But we try to understand that how the idea came up, and with the idea we'll be able to understand each and every concept of straight line. Don't worry about it. Stick with me. Okay, ji. Okay, sir, this point we can say some, let's say this point is, where is this point? This point is 2 units from this wall or this axis, and 4 units from this axis. So we said that, okay, 2, 4. Let's name the address 2, 4. You must have heard about rise and run, right? Run and rise. Run means in the horizontal direction, rise means in the vertical direction. In many books it is mentioned like that. If you have studied from I think IGCSE or IB board, then you must have heard about it. Okay, this is how it works. 2, 4. 2, 4 became the address. Let's say here, so okay, this point you want to know. There 4 in this direction, this is 4 units ahead in this direction, and 3 units ahead in this direction. Okay, so point became 4, 3. Horizontal distance we wrote first, vertical distance after that. Run and rise. Okay, this is how it became. So addresses came, all right. So now he was able to mark all the 3 points. The best part was he came up with an idea to mark or to locate or to name the 3 points. That was something exciting. This is something exciting. We have come up with an idea that we must be studying this from class 7th and 8th itself, but we never think it like this. Okay, these are the points. This is how we have named the points, let's say. Okay, now some patterns are also there. That suppose we didn't move in upward direction only. We were just moving in horizontal direction. Okay, we were just moving in horizontal direction. There was no upward direction. So this point will come, this point will come, this point will come, this point will come, all these points will come only in horizontal direction. We are not going in upward or downward direction. We are not moving vertically only. We are just moving on the corner of our room. Okay. So what all will be those points? Okay. Before that, he named a point as a coordinate as, now he said that coordinate, address means coordinate. He named it as coordinate. We can name it as coordinate. Coordinate, we said, okay, x comma y. Great. X comma y, he wanted to name the two axes. So he named the two axes and he said x comma y. All right, great thing. X comma y, no problem. Okay, keep listening to this. It might be hearing very easy right now, but you know, many bigger problems up to advanced level can be thought of. This is how you have to think with the problems. The formulas will not everywhere work. It might work in boards and all, sometimes in mains also, but definitely not at a good level. And these type of things, this idea of coordinate geometry helps in calculus also later on, vectors especially. Okay. Now, x comma y, name of the point. What did we say? We said that, okay, sir, x comma y is the name of that point. Now, what if I don't move in the horizontal, I don't move in the vertical direction. I don't want to move only in the vertical direction. So then I called, okay, all the points, all those points which are not in the vertical direction, which are moving only in the horizontal direction, where will all those points lie? Where will all those points lie? Where will all those points lie? All those points will lie here only. No vertical direction, only horizontal. Right? Only horizontal. This axis we called as y-axis, this axis we called as x-axis. That's something which you already know. All those points which will come only on this line. Only on this line. For example, suppose I want to go on the point which is let's say 1, 3. Right? 1, 3. I want to go on 1, 3. Randomly I'm taking. So what do I have to do? Okay, I have to just go 1 in the right side and 3 in the vertical side. This is 1, this is 2, this is let's say 3. In the vertical side, I came at this point. No problem. Very good. I came at this point. Okay, now let's suppose, okay, this is right side only horizontally I cannot move. I can move left side also. Okay, so no problem. -1, -2, -3. So left side I moved. Left side same point, left side 1 and vertically again 3 if I'll move. So -1, 3 it can be named as. It can be named as -1, 3. Not a problem. Right? Similarly, same thing if I do this side. That means 1 I moved right, but vertically I moved down. So it will become 1, -3. Great. And same thing if I do left side and down, then what will I have? -1, -3. -1, -3. Great. Nice way to, you know, locate, address the points, name the points. Where are we finding them? Where are we finding them? Now, obviously, your room cannot, your room can be like this also. Your room can be like this also. It's not necessary, you know, both the, sometimes we have that rhombus shaped or different shaped room. So the room can be like this also. But it was also possible that the coordinate geometry could be defined like this. And trust me, yes, this is also a way. This is called oblique axis. Right? Same thing if you tilt, it will become oblique axis. So it was not necessary to define differently. It was just called oblique axis. That means this angle is not necessarily 90. It can be anything. But we don't study about it. Right now we study about it in higher algebra or higher coordinate geometry, which we'll be studying maybe in college if you pursue with mathematics, that will be the case. Sir, when will you complete coordinate geometry? Straight lines, circles and conics. 3 things we'll do. And I think 1, 2, 3, 4 weeks. We will be moving a little bit slower. Okay. Slower and more effectively. That's the same. All right. Let's pay attention on this. So till now, what we are doing, just locating the points. Just locating the points. And that's how it is going on. No problem. Everything is going good. Some patterns we also observed. Some patterns also we observed. right? This pattern we observed that, okay, same thing, same point, same distance. If we are moving in opposite direction, this is how it's going to come. Here only, from this only, the idea of image point will be analyzed or indicated. Okay, one more thing. That, sir, okay, suppose I am already here, right? I am already over here. Right? Let's say this is 1, this is 2, this is 3. I am already over here, right? Now I want all the points. Now I want, suppose, first of all, before that also, one more thing, that if I want all those points for which there is no vertical distance, there is no rise, suppose I want all those points which have no vertical distance, will lie over here. Now if I want to find a way, if I want to suggest a way to tell that all those points should come which have no vertical distance, which are not moving vertically up or down, how will I write that? What will be the condition to write that? Right? Condition to write that. Obviously, for all those points, y will always be equal to 0. Right? For this point, if we talk about what is y, this is 1 unit we moved in horizontal direction and 0 units we moved in vertical direction. So 1, 0. Similarly, this is 2, 0. This is 3, 0. This is 4, 0. Now, every point is like this. Now I want to generalize this. How will I write that? I'll write it as y equal to 0. This is the condition of this line, that on this line y is always going to be equal to 0. Understood? Getting my point? Getting that feeling? And similarly on this line, x is always going to be equal to 0 because we are not moving horizontally. Now suppose if I say that I am already at 4 units, right? If I say I am already at 4 units, means at this point I am already here. But after that I am not moving horizontally ahead or back, I am just moving vertically now. For example, all those points, if I want all the points which are at 4 units from the vertical axis or the y-axis. Suppose if I want all those points which are at 4 units from the vertical axis, how will I write that? So these points are going to be there. These points, all these points are going to be 4 units from the vertical axis or the y-axis, you can call it. All these points also. All these points. This is how the idea of equation will generate in your mind. It is very important to develop the idea. Guys, it is actually very important. Sometimes, we think that this is something which we know. Those who already come, the students who cannot start with the scratch, right? It becomes a big problem with them. They'll always be like, no, this I know, let's chuck it. This is time waste. Nothing is time waste for these 2 years till you get into a good college, at least if not IIT, at least some good college, reputed government college. If you cannot get into, don't think anything is, irrelative or waste of time for me. Okay. If you're in 11th right now, it is very, very important to understand everything from the scratch. That will give you fundamental, ability of problem solving. Okay. Now all these points which are at 4 units from the vertical axis. Okay. 4 units from the vertical axis. That means this is always going to be equal to 4. No? So can I call it? What equation should I call it? This is always equal to 4. Can I just simply say x equal to 4 will be the equation? Yes or no? Now you'll start getting interested. Don't worry. Okay. It will become more interesting right now. X equal to 4 because x is always 4 on this. Similarly, if I just simply say that I want all those points that are at a distance from the vertical axis, I'll just simply say, okay, this means x equal to a. This is the condition for that. If I just say x equal to a, that means all the points which are at a distance from the vertical axis. Okay, similarly, if I want all those points which are at a distance of a from the horizontal axis, What will I call it? Simply y equal to a, because the y address will always be equal to a. So this condition satisfy all these points. If I want all the points, stop it, and related time, and we reach home and 5 to 5:90, sir, G, can you change the time? YTGT. Okay, pakka. I'll consider that, beta. I'll consider that. Don't worry about it. Actually, you know what happened? Okay, I'll consider that. I'll not make any excuse for that. But why generally the time is 4? I'm not saying that I won't change the time. I'll pakka do that. Don't worry about it. Why this time is 4 o'clock? No, because if suppose if a session is going longer, sometimes it has happened. Sometimes you'll see next week itself, it will happen. Sometimes if we take breaks, we get tired, or let's say the session gets too long, then it becomes 2:30, 3:30 also for us to go back home. And that time we don't find anything to go back home. So we have to stay. But yeah, don't worry about it. If it is your requirement, this will be. Even if it is midnight, we will watch. Thank you so much. That's very great. If you guys are motivated, it is motivation for us. That is motivation for us. That is definitely motivation for us. I'll do that. Don't worry. I'll just have a meeting with all the other the teachers also, and we'll do that. Okay. All right. So till here we are just exploring the points. We are just trying to invent the coordinate system, a addressing system, points, just points and conditions for those points. For example, just now we said all the points for which y is equal to 3. Y equal to 3. This is a condition. This is a condition for all those points. 1, 2, 3. All these points. All these points. Now over here, it does not mean that the address becomes same. Address did not become same over here. For this one, y is 3, but x is 1. For this one, y is 3, x is 2. For this one, y is 3, x is 3. For this one, y is 4, x is 3. Y is 3, x is 4. Like that, right? But one condition prevails, that for all these points, y is equal to 3. For all these points, y is equal to 3. And for all these points, x was equal to 4. Condition only is the equation, right? Anything else? Condition only is the equation, nothing else. This condition itself is the equation. What else is an equation? A condition which is satisfied by all the points. It can, for example, like if you have studied about parabola and all the other type of curves, quadratic equation also, that is also same thing. Condition which is satisfied, which is true for everything, which is true for every of the points. Okay. Let's move ahead now. Let's see some more things. Now, okay, this time something else. Then what we can think is, we understood what is an address, how we write an address, but now suppose we are talking about those points. Suppose if I move 1 unit horizontal, 1 unit vertical, which point I'll get? I'll get this point. Okay. Suppose if I'll move 2 units vertical and 2 units only horizontal, 2 units vertical and 2 units only horizontal, which point will I get? I'll get, sir, this point. Similarly, 3 units vertical, 3 units horizontal, this point. 4 units vertical, 4 units horizontal, 4 units vertical, I'll get this point. Right? 1, x is 1, y is also 1, x is 2, y is also 2, x is 3, y is also 3, x is 4, y is also 4, x is 5, like that. Same thing I can do this side also. X is minus 1, y is also minus 1, x is minus 2, y is also minus 2, x is minus 3, y is also minus 3. Okay. Wow. What are we getting? We are getting a different kind of line. If we'll connect this, and what will be the condition of this line? Can you tell me, guys? Simple condition, sir. X and y both are equal. This is the condition, and this only is the equation. X equal to y. Correct? X equal to y. right? Simple thing, x equal to y is the equation. Whatever you put x as 1, y will also be 1, x is 2, y is also be 2, x is minus 1, y is also minus 1, x is minus 2, y is also minus 2, x is minus 3, y is also minus 3. Line. Can this type, only these type of lines can be there? No. There can be one more thing. Suppose if x is, suppose if I move backwards horizontally, that means if my x is minus 1, but y is 2. But I'm moving upward direction. X is minus 1, y is 2. Sorry, x is minus 1, y is 1. Sorry. X is minus 1, but y is 1. X is minus 2, y is 2. X is minus 3, y is 3. Somewhere over here. So this is another line. This is another line. And it will keep going on like this. Don't mind my drawing. See, I did not bring the PDF notes because this is how you'll get the feeling. You also keep doing this with me. Keep your pen notebooks. If you cannot do it right now, then watch this again and that time you do. But think like this. Start thinking like this. That's how we can become stronger at the fundamental solvings. Okay. Sir, x is minus 1, y is minus 1. Here you can see x is 1, y is minus 1. X is 2, y is minus 2. X is 3, y is minus 3. X is 4, y is minus 4 and so on. That means whatever is x, same thing is y but with an opposite sign. Can we simply say x is equal to minus y? This will be the condition. This color is not visible, kya? Let me see. Okay, I'll use something else. X equal to minus y will be the condition for this line. This will be the equation of this line. Very nice. And we know we have seen this line so many times, but we actually never project it like this. I don't know, you have, then it's good, but I just wanted all of you to think it like this. Now sir, suppose, let's think of something more. Okay, this is okay, this is very good, this looks beautiful, that we can actually see what will be the line which will represent x equal to y. Every point, x is 1, y is 1, x is 2, like that. All right. But sir, suppose if we are moving vertically 1 unit, but sorry, we are moving horizontally 1 unit, but vertically we are moving double of it. That means horizontally 1 unit. I'll take another. Okay. Okay, just for now, just roughly I'm making. So suppose horizontally I'm moving 1 unit, vertically I'm moving double of the horizontal movement. That means 1 I'm moving horizontally, 2 I'm moving vertically. 1 I'm moving horizontally, but 2 I'm moving vertically. When I'm moving 2 horizontally, I'm moving double of 2, that means 4 vertically. Correct? And for reference, this is my line which I made just now, right? This is my y equal to x, where same movement horizontally and vertically I had. But this time I'm doing something different. What am I doing? When I'm moving 1 unit horizontally, I'm moving 2 units vertically, 2 units horizontally, 3 units vertically, 4 units vertically, 3 units horizontally, 9 units vertically. So you can see, right? You can feel that this line is going to be somewhat like this, right? This line is going to be somewhat like this. What happened? And what will be the condition? Y is twice of x. Y, that means y movement is twice of x movement. Whatever, if x is 1, y is 2. If x is 2, y is 4. Great. Y is equal to 2x. If I do y equal to 3x, where will it come? Can you already guess? If y is equal to 3x will come here. Right? Actually, I tilted it a lot. It won't be like that. But y equal to 2x, y equal to 3x, like this. All these lines are going to be a bit bended. a bit bended from y equal to x. Which side they'll bend? On this side. They'll bend on this side. They'll bend on this side. Correct? Getting my point? Now, if suppose if I do, I don't want to double it. I want to half it. Right? I want to half it. If I'm moving, if x is 1, then I want y should be half. If x is 1, then y should be half. So it will come over here. If my x is 2, y should be 1. So it will come over here. Right? If my x is 3, y should be 1.5. Somewhere over here. So where will this line come? Where will this line come? Where will this line come? This will come. I'll change the color. This is your y equal to x. Okay. This is your y equal to x. This is how. This yellow one is your y equal to x. When I'm doing y equal to 2x, I'm going above, or you can say I'm tilting this side. When I'm doing y equal to 1 by 2x, right? X is 1, y is half of 1, that means 1.5. When x is 2, y is 1 only. When x is 3, y is 1.5. When x is 4, y is 2. So this line, can you see this line? Where is this line going? This line is going, this line is going like this. What is the condition over here? Y is equal to x by 2. Y equal to x by 2. Now can you get the idea what are we actually trying to do? What actually we are trying to do? So there is something multiplied with x which is changing the direction of the different lines along y equal to x. Along y equal to x. There is something multiplied with x which is actually changing the angle, you can say, or direction or tilting of the line about y equal to x. If I'm taking a number more than 1, right, then I'm moving this side. If I'm taking a number less than 1 and multiplying it with x, then I'm moving this side. Okay. So something is multiplied. Can I just simply say y equal to mx? I know you guys know what is m. If more x-axis less y-axis, then angle will be more, correct, right? So y equal to mx, we can always say that y is always y is always going to be equal to mx for all these type of lines. All these type of lines. And here only, if we can say that if my m is greater than 1, if my m is greater than 1, then the lines which I'm going to get will be in this region. Will be in this region. Right? Will be in this region. And if my y is less than 1, if my m is less than 1, if my m is less than 1, then my lines will be in this region. Obviously backside also and this side also. Very roughly I'm making, but you make on your own and understand this. Still your y is equal to x is your this yellow line. So if my m is greater than 1, then I'm getting lines over here, right, in this particular region from here to here. I'll explain why we are not going beyond it. From y equal to x is here, and if I'm increasing the value of m greater than 1, if I'm putting I'm getting all the lines which are going to be in this region. And if my m is less than 1, then I'm putting all these lines, then all these lines which I'm getting, which are in this pink region, you can say, all these pink lines, all these lines will come, all these lines, and they are going to be extended over here also, right? To make it a bit more clear, I'll make it a bit more clear. So this is, let's say, your y equal to x, right? What did we just now see? Y should be equal to m times of x. Y should be equal to m times of x. And if my m is greater than 1, if my m is greater than 1, then what am I observing over here? That all these lines I'm going to, I'm getting all these lines, and these will be too many lines, a lot of lines, y is equal to 10,000x, no problem, all these lines I'm getting. If my m is less than 1, then I'm going to get all these lines. Okay, and this is my y equal to x. Nice observation. But one more thing can be done, right? Here one more thing can be done. Sir, what if you create y equal to minus x? This same thing will happen about this also. Y, m is greater than 1, m is less than 1. M is greater than 1, m is less than 1. Okay, no problem. Just a minute. Okay, m is greater than 1, these lines, m is less than 1, these lines, but less than 1 till here, till where less than 1, greater than 1 till infinity, no problem, till infinity, that means any number of lines, greater than 1 to infinity. So now we can break this more, that m is greater than 1, okay, m is greater than 1, one condition, m is less than 1, but how less? Till 0 only, no, because this line, which is this line, this is y equal to 0, here m is 0, here m is 0, so y equal to 0, this is our horizontal line. So from 1 to 0, m less than 1 but greater than 0, this is one condition which is for green lines. Now m can also be minus 1, right? For this line m is minus 1. So one more condition, m, for this line m is minus 1, right? For this line your m becomes minus 1. We are defining y equal to mx. So for this line your m is minus 1. Here what is multiplied with x? Minus 1. So okay, 1 to greater than 0, less than 1, but now greater than minus 1 but less than 0. That means m is greater than minus 1 but less than 0. Can you tell me all these lines? Where will all these lines come? Sorry. M is greater than 0 but less than minus 1. Greater than 0 but less than minus 1. Is this correct? No, this is not correct, right? M is less than 0 but greater than minus 1 only was correct. Sorry, my bad. M is less than 0 but greater than minus 1. Here m is greater than 0. But now m is less than 0 but greater than minus 1. Where will all these lines fall? You can check yourself. Where will all these lines fall? These lines will fall in this region. All these lines. Right? All these lines. For these lines, m is greater than, m is less than 0 but greater than minus 1. For these lines, m is less than 1. M is less than 1 but greater than 0. M is less than 1 but greater than 0. For all these lines, m is greater than 1. Correct? What is remaining now? What is remaining? What if m is even less than minus 1? Suppose if I take y equal to minus 2x. X is 1, y will become minus 2. X is 1, y will become minus 2. That means here, right? X is 2, y is minus 4. X is 3, y is minus 6. So these lines are still remaining. These lines are still remaining. For all these lines, what will happen? For all these lines, m will be M will be greater than minus 1, but greater than minus 1 only is okay. Greater than minus 1 only is okay. All these lines. Less than minus infinity, actually you should write, and here we should write greater than 1, less than infinity. But there is no need. If M is greater than minus 1, that is also correct. Right? All these lines. Why am I calling infinity? Think about it. Why am I talking about infinity? Sir, infinite. So obviously, infinite lines can be in this section. Greater than 1, y is equal to 1 crore x will be somewhere near, but will be over here only, in this section. Correct? Somewhere over here only. Somewhere over here only. So that's why from 1 to any point, right? Now this equation will become x equal to 0, right? Because y divided by infinity will become divide by infinity means 0, right? No need to get into that right now. You can just simply understand that greater than 1 can be anything. Less than 1 till 0, that means this section. Okay. Greater than 0 but less than minus 1. Sorry, less than 0 but greater than minus 1 will be this pink section. And then greater than minus 1 will be this blue section. So now you know that this is how the idea of M is developing. You can simply say, sir, if I simply give you a line, sir, y is equal to, y is equal to 6x. You can say, sir, this is going to be above y equal to x. If I give you y is equal to minus 6x, then you can simply say that it is going to be on the right side of y equal to minus x, somewhere between these two. Okay. So this is how you can develop this idea. And but till now, have we covered all the types of lines? Have we covered all the lines? Have we plotted all the lines? No, we have not plotted. We have not plotted all the lines yet. Have we or not? And also, one more thing, we define this. What is this M actually? What is this M? When I'm saying this line is y equal to 2x. If I'm saying this line is y equal to 2x. This coefficient of x is actually deciding that suppose if I sit on this line, then how quickly will I fall? If I sit on this line, which is y is equal to x by 2, okay, let's say. So on this line I'll fall faster, on this line I'll fall slower, something like slope. So we give that M is nothing but slope. M is nothing but slope. Slope, idea of slope came. How steep is your line? How steep is your line? That's what was that's what is the idea of our slope. Okay, correct. Now steepness, if we are talking about, then how will we calculate this steepness? Steepness, you can say rotation, you can say, or you can simply say in simple words, in defined words. If you want to define it, how can we define it? Okay, we'll call it that some angle. How tilted is your line about your horizontal axis? We have to define everything. Then only we can approach towards maths. So how tilted is my line from the horizontal axis? That's what I'll say. For example, this line is tilted like this. This line is tilted like this. Let's say this is theta 1, this is theta 2. Okay. Now if tilted I want to find, there is only one way, because I have only defined rise or simply just vertical distance by horizontal distance. Right? This tiltedness, this tilt or this turn or this rotation will only be defined in one way. How high and how far. For example, this is far, both of these lines at this point, if we talk about, they are similarly far from vertical axis. That means in horizontal direction they are equally far, but in vertical direction they are differently far from the horizontal axis. So this is, let's say this is at some y2, this is at some y1. Both are at x1. Both are at x1, x1. This is also x1, this is also x1. right? But this is more steep, this is less steep. Why? Because of this angle. And we have talked, or we know the basic thing about trigonometry, that sir, if we are talking about this angle, no, this angle is being decided by this distance and this distance, two distances. That means perpendicular upon base. Perpendicular upon base. Perpendicular upon base. So we say that, okay, tan theta is deciding your rotation. Tan theta is deciding your steepness. Perpendicular upon base means tan theta. So tan theta is your m, or this is also called your slope. That's how we came to the idea of slope. Okay. Now this theta, obviously this theta. Now suppose if I'm talking about this line or this line, this part, this is same line, this is the same line, this is the same line, correct? This is the same line. So which theta should I take? This theta or the complete this theta? Right? Theta 2 or this theta 2? No, I'll take obviously this theta, because that will be same. So if whenever I'm talking about the inclination, or whenever I'm talking about the steepness, or now we can talk about the word slope also. If I'm talking about slope, I'll always take it from the positive direction of x-axis. That also I defined, that also we define in mathematics, that okay, whenever we'll talk about the slope of a line, we'll take the angle from the positive side of the x-axis. This much we can easily understand. What is the slope? Idea of the slope, simply this perpendicular upon base only is deciding, no, how steep is your line with respect to your horizontal axis. This is more steep because tan theta is more. Now tan theta is deciding, okay, from where to where can your tan theta be? From where to where can your tan theta be? I mean, like, what can be the range of your theta? This theta, what can be the range of your theta? Tell me in the comment box. 1 to infinite, nahin? How 1 to infinite, beta? Theta can either be 0 or it can be 180. Correct? 180 and 0 also same. Tan 0 and tan 180, same thing only. Correct? So theta can be from 0 it can be, right? 0 will put in the closed interval. It can be 0, no problem. If we are including 0, then why is there a need to 180? Tan theta equal to 0, that means m is equal to 0. M equal to 0, that means y equal to 0. Y equal to 0 is the equation of which line? Horizontal line only. Right? If I put tan theta or tan 180, tan 180 will also become 0. M becomes 0. Same thing I'm talking about. No. So if I'm including 0, there is no need to include 180. Makes sense? Acha. Theta, not tan theta. Tan theta can be anything. Tan theta's range is, yes, you're correct. Right? No need to include 180. One more thing I cannot include. What I cannot include? This angle cannot become 90. M cannot become 90. Otherwise, this line will come. This line is coming. This is already defined as x equal to 0. Or if you're putting 90 also, this is the extreme case. That we are not including. So we'll have to disclude 90. Will not put 90. Theta cannot be equal to 90. Correct? 90 means, this line will come. No, perpendicular. The line which we are taking for reference only came. This is already defined. We are talking about the lines which can be addressed or which can be made in this particular system, coordinate system we can call it, right? Axis system we can call it. Simple to understand? Anything which bothers you till now, please tell me. Okay. All right. So this is the idea. Great. Now, as we have spoken about the slope, but just now we said that, sir, before the slope, one more thing, before we move ahead with slope, one more thing, did we actually encountered or plotted all the lines? All the lines which we made till now, over here, everywhere, were only passing through origin. What about this kind of line, or this kind of line, this kind of line, any kind of line? Let's take a simple case. Let's talk about this line. What about this line? Is y equal to x over here? No. Y is not equal to x over here. Okay. Or let's take this line only. No problem. Let's take this line. Right? But if I make change the color, no bro, what is happening? If I make y equal to x, this line is just parallel to y equal to x. What did I just do? I just shifted y equal to x, no? This much. I just shifted my y equal to x, this much. So for this also I can make the condition very easily. This is y equal to x. Right? Suppose if this is 1, this is going to be, this is 1, this is 0, this is 0, x is 0, y is 0, x is 1, y is 1, x is 2, y is 2, x is 3, y is 3. Now over here what is happening? When x is 0, y is, let's say, some 5. Okay, when x is 0, y is 5. Now when x will be 1, y will be something plus 5. Y will be x plus 5. That's it. Y will be x plus 5. Right? If suppose if this line only shifted 5 units ahead, up in the upward direction. Right? So for this one I can simply write y is equal to mx was this line. Y equal to x is the general case. Y is equal to mx is the general case. No, it can be any line passing through origin. And that line passing through origin is shifted by some units. So this is going to be just y is equal to mx plus 5. And now let's generalize this. Let's just simply generalize this. I'll not say 5, I'll say c units. I just shifted my y equal to mx 3 units, c units upwards. So this is going to give me y is equal to mx plus c. Now I have plotted all the lines. Now suppose in the same scenario, I want to say that where will be my y is equal to 2x minus 3. So first I'll see where is my y equal to 2x. First I'll see, okay, y equal to 2x. Y equal to 2x will be a line passing through origin. Minus 3. That means in the lower direction I have to shift downwards. 3 units downwards. So that means this line will be my y equal to 2x minus 3, and this distance will be equal to 3 units. This point will be equal to 0 comma minus 3. Getting my point? Understanding the idea behind y equal to 2x minus 3. We simply write this equation, but we don't think of it or understand it this way. Okay. Okay, y equal to 2x minus 3 simply means y equal to 2x is shifted 3 units downwards. If I do y equal to 2x plus 3, then it will be like this. This will become y equal to 2x plus 3, where I have just shifted y equal to 2x 3 units upwards. That's it. Nothing challenging, nothing major I have done. So I said no, y equal to mx is not the general equation of my line. Any line if I want, this will give me any straight line now. Any straight line. This is going to give me any straight line in the world now. Not a problem at all. Any straight line in the world. But idea is that every straight line is made or is looked at as or visualized by the means of a line which is going to pass through origin. Any line which is not passing through origin also, but if you want to visualize it, it will be visualized by the means of a line which is passing through the origin. For the equation with respect to x-axis, for the equation like x equal to something. Arey beta, x equal to something or y equal to something, x equal to something and y equal to something are the lines are going to be the lines parallel to x and y axis, na? We are talking about the lines which are, we already spoke about these kind of lines, na? These kind of lines. or these kind of lines. These are all these are y is equal to a or y is equal to b, something like that. These are all x is equal to a, x is equal to b, like that. Passing through origin we made. Now which are not passing through origin also we made. Correct? I hope I'm getting your doubt clearly. Write it again. I'll wait. Just drink water. Correct, no? I got your point, no? Okay. Great, amazing. See, to solve the problems which we are going to do in the next session, to solve the to solve all the PYQs, you have to understand these small points. Although generally we don't teach in this much of depth. Suppose it was an offline class, or let's say you had less time or something like that. There is no need for nobody will tell you this much, because everybody expects that you know this much. But do we actually know? Have we ever thought it like that? X is equal to y minus c by m. Arey, to same y is equal to mx plus c only, no? For x is equal to y minus c by m, same thing is manipulated, beta. Same, that is equation manipulation. That's not coordinate geometry. That's not coordinate geometry. That same thing you are manipulating. You are writing x in terms of y. So same line will be same only. Will it change the line? It won't change the line. It won't change the line. If I write x is equal to y minus c or y minus c by m. Okay, it won't change the line, na? Both are satisfying the same condition. Nahi? Understood or not? Both are satisfying the same condition. Y is equal to 2x or x is equal to y by 2. Both are satisfying the same condition, same equation only. Line will be same only. I'm just trying to make you what will be the equation of theta taken with respect to y axis. Pi minus theta, beta. Simple. Suppose if I'm taking this as theta, then this will become pi minus theta. But that is why we define. That is the reason we define that tan theta, where theta is the angle with respect to x-axis. Suppose if they give you this theta, suppose in some question they say the angle which the line is making with y-axis is theta, then you take this as pi minus theta. In this case your slope, that means your m will become tan of pi minus theta, minus tan theta it will become. Correct? In that case it will become minus tan theta. Suppose I understood what you are trying to say. Suppose this is my slope, this is my theta now. Correct? This is what you are talking about. This is my theta. Pi by, pi by 2 minus theta. Sorry. Pi by 2 minus theta. Pi by 2 minus theta. Correct. Pi by 2 minus theta. Right? This will become pi by 2 minus theta, or cot theta it will become. Right? Cot it will become. Suppose if this is the case, that this is your theta, then you are supposed to take in positive direction. You are supposed to take your angle. That means your angle should be in positive direction. Slope of this line will be tan theta only. Slope of this line will be tan theta only. But theta is this angle. But suppose they are giving you 120 degree. They are saying that, okay, sir, what is the slope of line which is 120 degree? Right? Which is what is the slope of line which is making 120 degree with the x-axis, positive direction of x-axis? Sir, notes of the class where we can get, I'll upload it after this session only. In the description you will find. Suppose this is 120 degree. 120 degree means was pi by 2 plus 30 only. No, this becomes 30. Either you write this as 30 or otherwise this as 60 and this as 30. If this is pi by 2 plus theta, this will be 60 only. This will be 60. So 120 also you can write like this. No, tan 120, how will you write? Pi by 2 plus 30. This you know how to solve. Correct? Minus tan 30 it will become. So negative answer will come. Slope more than 90 degree will give you a negative answer. Correct? Negative answer will come. That's it. Now slope, basically when we are talking about slope, shall I remove all this, right? This is not needed. I hope you understood what I mean. If it is more than 90 degree, you have to go with the defined idea that I am going to take my angle of the line from the positive direction of x-axis only, right? And now if you are thinking, sir, what about more than 180? That won't happen. That will not happen, right? Because this, from here to here only can the angle be. Line will get rotated. Otherwise, line itself will get rotated. But if it is becoming more than 90, that means like this, then you'll break it like this, tan of 90 plus theta, and it will give you a negative answer, right? Negative answer. Cot mein, yeah, answer will come in cot, but value will become negative. We are talking about value. Yeah, answer will come in cot only, but value will become negative, na? That's what you are writing. Correct? Value will become negative. Negative slope you are getting, that means something like this. And arey baba, in starting, what did we discuss? Look at these. What about the pink lines? Pink lines less than 0 but greater than -1. Correct? What about the green lines? What was about the green lines? Sorry, not green lines. What? Pink lines and blue lines. Right? Pink lines less than 0, greater than -1. Blue lines were greater than -1 also. Correct? So negative slope will be for this blue and pink region. Positive slope will be for this region. 0 to 90. More than 90, that means this region, slope will be negative. Positive slope means this region. Either greater than 1 but less than 90, greater than 1, right? Or less than 1 but greater than 0. That means first quadrant. In that case, slope is positive. Second quadrant, only first and second quadrant it will be right about. In second quadrant, it is going to become negative slope. Okay, ji? In that also you know the specific cases now. So what did we understand till now? We have understood that, okay sir, y is equal to mx we can visualize. In y is equal to mx, all the different cases for m greater than 0, less than 1, greater than 1, less than 0 but greater than -1, less than -1 also, 4 cases, all 4 cases we can now understand. And we also understand that y is equal to mx plus c is actually the condition for any straight line possible. Okay, any straight line possible. Here if c becomes 0, that means line is crossing through origin. If c has some value, that means the line is shifted up or down from y is equal to mx. C is telling you the shift or y coordinate. Y intercept. This C is your y intercept. This you know, but you can also note it somewhere that this C is nothing but your y intercept, where your line will cross the y-axis. Because line will be shifted, we are talking with regards of x-axis. So line will be shifted upwards or downwards like this only. Now next thing. Sir, anything more? Anything more? Yes. How? We cannot always look at this angle. No. What if angle is not given? What if angle is not given to me? 2 points are given to me and a line passing through these 2 points is given to me. This is one way of looking at a line. Sir, 2 points are given to me and I want to talk about this line. I want to write the equation of this line which is passing through these 2 points. I just know one thing till now, sir. Line can be written like this: y is equal to mx plus c, where m is the slope and c is your intercept. Y-intercept. This is the only way I know. Acha, okay, no problem. Try to think, try to write this once according to your own understanding, whatever your understanding. Two points, what we can say, let's say this is my x1 y1, this is my x2 y2. Okay, no problem. If I want to think in this direction, I can say this is my x1 y1, this is my x2 y2. All right. And if I want this angle, whatever is this angle will same be this angle. That I know. This angle and this angle, because this line and this line are parallel. If I just make a horizontal line along this point, this angle and this angle will be equal, corresponding angles, parallel lines. Okay. If I'm talking about this angle means this. What is this angle? The tan of this angle, tan of this theta, that only is my slope. That only is my slope. That means my m, which is my slope, is nothing but this distance divided by this distance. What is this distance? This distance is y2 minus y1. And this distance, horizontal distance, this much distance is x2 minus x1. So I can simply say my m, tan theta, is perpendicular upon base, which is nothing but y2 minus y1 upon x2 minus x1. Now I said, okay, instead of taking 2 points like this, let me clear it a little bit so that less hodgepodge is there. Instead of taking x1 y1, if I want a condition, that every condition which is satisfied, eventually if I'm writing equation, I want a condition only, right? I want a condition which is satisfied by every point on a line, which is satisfied by every point. In that case, what should I do? That only is my ultimate goal. That only would be my ultimate goal, right? If this is my, suppose this is some point x comma y. Now I want that any point, I want all those points, let's think it like this, I want all those points which will be at the same inclination, I think I should make it, make you visualize in a bit different way. Let's think it like this. Let's think it like this. Arey baba re. Let's think it like this. Okay, think it a little bit different way. Suppose this is my point x comma y, some point. I want to generalize one more way of looking at the equation of line. One way I know, y is equal to mx plus c. This is one way I know. But now I don't have. I just want to know, is there any other? Can there be any other way in which I can visualize or in which I can write the line? I thought, okay, x comma y is a point in a coordinate system. It's a point. Now I'm thinking that, okay, what do I want? I want a line and I want a condition for that line. I'm just trying to look at another method of writing that line. For example, this is your slope intercept form. Although you don't need to mug up all the forms by their names, there is no need like that. You just understand in what ways can you visualize or in what ways can you write a line. In what ways can you write a line? Suppose now x comma y is a point. Now if I want a line, by line what do I mean? By line what do I mean? That I know that this point is inclined with theta angle. If I connect origin and this point, this is inclined with theta angle. Okay, this is inclined with theta angle. But now I want all those points which have the same inclination, same slope. Now I'm looking for, if I want to write a line, what am I actually looking for? Think like that. I am actually looking for all the points which are at same inclination, same slope, same theta. This is theta, this is theta, all these are theta. For all of them, it should be theta. That's what I want. Then I thought, okay, but again, the problem is, how do I write the condition for it? Can somebody tell me what I'm trying to do? Which direction am I moving in? I am saying that I want all those points which are at same inclination. So I took one more point. Let's say x1, y1 is also on the same inclination, right? If it is on the same inclination, then here I said, okay, y2, sorry, not y2. I said y1 minus y will be this length, and x1 minus x will be this length. And I know this angle tan theta will be nothing but y1 minus y upon x1 minus x. This m will be nothing but y1 minus y slope tan theta. This tan theta will be perpendicular upon base. That means y1 minus y upon x1 minus x. Right? From here only I am getting another form. From here only I am getting one more way to write a line. If I just shift it, what will I get? Y minus y1 is equal to m into x minus x1. This is called as this in now. This is what we call as, if you want to name it. Oh shit! Sorry. Ouch. This because whenever I have to teach for longer hours nowadays, I've stopped wearing the shoes. Those make me more tired, but there is a risk of getting hurt. All right. Where were we? This is called, what is this you have seen? Y minus y1 is equal to mx minus x1. This is point slope form. If you want to name it, it can be called as point slope form. Okay, point slope form, right? Point slope form. But what did we do? Actually, we are exploring the same idea only, no? Same idea. This is one more way, and this is most efficient. This only is the father of the other ways, you can say. Okay, this only will be called as the father of the other ways. Okay. Now here, suppose now in the same case, I have 2 points now. Suppose I just have 2 points. One point is x1 y1 and this is x2 y2. Okay, I know that, sir, if I want to write the slope of this line which is connecting these 2 points, a line which is connecting x1 y1 and x2 y2, right? This time I don't have slope or anything. I just have 2 points. Suppose there is a scenario, I just have 2 points, any 2 points, and I want to write the equation of line. In that case, what will I do? I'll just take this, and here only I'll just put y minus y1 equal to y2 minus y1 upon x2 minus x1 into x minus x1. That's what. That's it. And this I'll then name it. There is no sense in naming, but yeah, I'll name it as 2-point form. I'll name it as 2-point form. This session, yeah, definitely, Adarsh. Till the time the channel does not become very big, but you can utilize it like that. We are trying our best. Okay. But yeah, every channel is like this. It takes years to grow and lot of efforts to make a channel grow. All right. Anyway, we'll not get into all that. Understood? Y minus y1 equal to y2. Now m I know is slope. Suppose I don't have slope, but I have 2 points. From 2 points, what I can do? From 2 points, I can just simply find the slope, and then I can put it in same slope, point slope form. So that's why I said this is the main form that we have, right? Now suppose one more thing we can do this time. So what did we see? We saw slope intercept. We have slope and we have intercept. Y-intercept if we have, and we have slope, we'll use this. If we have slope and any one point, we can use this. If we have 2 points, then we can use this. Sometimes what will happen, that we have this length. This is A, this is B. Sometimes what will be the scenario, that we are going to have this length instead of something else. Just a minute. Right? Sometimes we might have these lengths, intercepts of the line. This is A, this is B, let's say. Right? In this case, what will happen? In this case also there should be a way to write the line. Same thing we are doing in different ways, okay, same thing. But what will be given, according to that, how will we think about the problem solving? That's very important. Suppose these intercepts are given to us. This distance is A, this distance is B. Okay, ji, no problem. If this distance is A, this point will become what? This point will become A, 0. And this point will become 0, B. X is 0 here, Y is B. Y is 0 over here, X is A. Okay. I'll again use my 2-point form only because I have 2 points, right? I have 2 points now. Y minus Y1, I'll write it. Y minus Y1 equal to M X minus X1, or instead of M, what will I write? Instead of M, I'll write Y2 minus Y1 upon X2 minus X1 into X minus X1. Correct? I'm doing the same thing. I'm using this thing only. 1-point form only I'm using. Here also used 1-point form. If I'm having 2 points, then I'll just need slope. Right? Here also I have 2 points. So I'll use, you can call it 2-point form or 1-point form only in 2-point way. Okay. So Y minus Y1, these Y and X are parameters basically. Right? That won't change for the equation forming. Y minus Y1, Y minus, take anyone as Y1. Let's say this is X1 Y1, this is X2 Y2. So Y minus 0 equal to Y2 minus Y1. That means B minus 0. That means B. Upon X2 minus X1. That means 0 minus A. That means minus A. Into X minus X1. That means X minus A. What are we having? What do we get? Y equal to minus B by A into X minus A. Correct? Take this side, AY equal to minus B X or minus BX plus AB. Correct? Minus BX plus AB. This is what it will become. I'll bring this side AY plus BX equal to AB. Divide everything by AB. What do we have? Y by B, or simply X by A. I'm writing first X by A plus, from here I'll get Y by B equal to 1. This is also one way. If I'm given intercepts, then this beautiful condition comes, which is called as intercept form. Which is called as intercept form. Okay. All this idea, where did it start from? You see, everything which we are doing right now, where did it start from? It started from a simple problem. What was the problem? Anybody can remind me? Ashwath? Simple problem, that finding the point inside the triangle formed by 3 points. Okay. So researches happen like that. Mathematical thinking should be developed if you are appearing for an exam like JEE. I'm not only talking about maths, it will be applying on physics also. Same thing is applied on physics along with imagination. In maths, you don't need imagination. In maths, you just need patterns and solving methods. Okay. But yeah, same thing only we are doing. Till now, anything different you saw? Anything different you saw? No, right? So this is intercept form. Same thing I wrote, manipulated it into a different form here, A and B. Suppose if I simply have, sir, x by 3 plus y by 4 equal to 1. Okay, equal to 1. What does it mean? That this is this line. Here it is 3, 0 and here it is 0, 4. I can simply mark. Okay. Okay. Suppose if I have a different line, suppose I have 3x plus 4y equal to 16, or let's say 12, or yeah, take some other number also, 16, not a problem. Now what will you do? You want to know the intercepts. Obviously this is a line, this will also have intercepts. Yes or no? Can you tell me the intercepts over here? Come on, try it. Four comma 16 by 3. 5 आएगा ना? It should be 5. Okay. First you'll create a 1 over here. First what will you do? You'll create a 1 over here. So in that case you'll have to do 3 by 16. Correct? Plus 4 by 16. Y equal to 1. But 1 got created, but you want these to be down. You don't want them to be over here. Correct? So what will you do? You'll divide by, you'll divide by LCM of these two. Right? You don't want a coefficient of x over here. You want a denominator of x. So in that case, what will you do? You'll multiply by 16 and divide by 3. But here you cannot do that. Okay, Visual Story, you are there. Okay, tell me. Come on. I'm still waiting for answer. Whoever is there, please give your answers. I'll just drink water and come back in a minute. Please hold on. I'll just be back in 2 minutes. Yeah. Yes, Ashwat. That's what I was expecting. Actually, I was just checking that are you applying that square root of a square plus b square? I was just checking that, because if you are giving me answer according to square root of a square plus b square, no, that means you are still not still not trying to learn it from the scratch. Here you simply write, no, x by 16 upon 3 plus y by 16 upon 4, that y by 16 upon 4, 1 by 4 or 4 by 1, just y by 4 equal to 1. Here the simple way is that here we can simply write it like this. There is no problem. Why to generally, if in generalization there is a formula that we will come to know now. This was slope intercept form. Okay, now there is one more way. There is one more way. Can we write, sir, TQ today my maths exams are very good, mom's race. Okay, great, amazing. That's good mark. That's good mark. Try to improve it, try to increase it, solve some more problems. Very good, bete. Now see, there is one more way of writing a line. There is one more way to visualize a line or write a line. Sometimes they'll not give you anything. Okay, what they'll say, that there is this line, and this line is at a p distance. This line is at a distance of p from the origin. In question also they might give you, this is one form also, but think of it like a problem, that there is a line. Okay, listen carefully. There is a line which is at a p distance from the origin. The line is at a distance of p from the origin. Okay, getting my point, understanding my point, what I'm trying to say? The line is at a distance of p from the origin. That's it. No need to complex your problem, no need to complicate your problem. Okay, distance of p. One more information they'll give you. The slope of this perpendicular line, okay, the slope of this or the angle which this perpendicular is making is some alpha. This time we are not using theta, is some alpha angle. Okay, line is at a p distance from the origin, and the inclination of this p distance, this line, this perpendicular line is alpha. This is not the, don't think that the slope of line is alpha or tan alpha. No, slope of line is not given to you over here. Two informations are given to you, that what is the perpendicular distance of this line from the origin, and what angle is the perpendicular of this line is making you, and or you can say that this perpendicular line is also called as normal, right? Perpendicular to line is also called as normal. Okay, right now there is no need to be into that direction. But now what do we do? Now how do we write the line? Okay, let's think about it. We know trigonometry. We know simple trigonometry. We know this is alpha, this is 90. We know this is going to be 90 minus alpha. Any problem? No problem. Okay. See, if we are thinking about it as a problem, just think, no, if we want to write the equation of this line, what do we need? 2 points we need. For let's be fundamental, very fundamental. First thing, here what we learned, we need 2 points. Either we get the slope or we get 2 points. Either we get a point and slope or we get 2 points. Here we are not getting the slope. So we'll think about 2 points. Okay, we'll think about 2 points. You must be thinking, sir, if this is alpha, this is 90 minus alpha. Sir, this is 180 minus 90 minus alpha. Sir, this will be alpha only. 2 alpha. That won't help. That will take you into tan 2 alpha, which is 2 tan square alpha upon 1 minus tan 2. All those formulas will start coming in that case. Okay. Correct? Right? Double angle formulas you'll have to use that. There is no use of that. So think it other ways. So now what we can do, what we can think of is, sir, if we get 2 points, which 2 points can we get? Sir, this point and this point we can pakka get. How will we get? Sir, this is alpha, this is 90 minus alpha. Okay, great. This is also a right angle triangle. This is also a right angle triangle. This is 90 degree. In this is 90 minus alpha, this is 90. Okay, this will be 180 minus 90 minus 90 minus alpha. 180 minus 90 minus 90 minus alpha. Right? Or simply just this. 90 plus 90 minus alpha. Correct? So what will this become? 90, 90, 180 gone. Minus, minus will become plus. This will also be alpha. Sir, why are you doing this? If we are able to do this with angles, I can say, if I have this as alpha, if I have this as alpha, here I have this one as alpha. This is alpha in this right angle triangle. Look in this right angle triangle. Just look in this right angle triangle. This is hypotenuse. This is your, for this angle, for this alpha angle, this is your perpendicular and this is your hypotenuse. Correct? I have this. What should I apply? I have base, I want hypotenuse. Cos alpha will be equal to this P, that means base, upon hypotenuse. Correct? So hypotenuse will be equal to P upon cos alpha. P, solve it on your own. P upon cos alpha, can I say? This distance I got. Similarly over here, this is 90 degree. This is alpha. For this alpha, this will be perpendicular. This will be hypotenuse. This will be perpendicular. This will be hypotenuse. Sin alpha will be equal to P upon hypotenuse. Hypotenuse will become P upon sin alpha. This distance will become P upon sin alpha. See, I'm taking time. Although there is no need to get into this much of derivation, if I'm taking time, solve it along with me. Even if you watch the recording later, try that you do these things on your own once. Fundamental understanding is very, very important. Okay, and let me know how do you feel about it. Okay, P upon sin alpha, this thing came. Now what? Nothing is left. This is what? 0 comma P upon sin alpha. This is what? P upon cos alpha, comma 0. We got 2 points. Or even if you leave 2 points, we know slope intercept form, we know intercept form, na? Intercepts we have 2 points also. If we just let them go to hell, 2 points, we have 2 intercepts now. We know the intercept form, x by a, that means this intercept, x by p upon cos alpha plus y by p upon sin alpha is equal to 1. What is this giving us? This will give us x cos alpha upon p plus y sin alpha upon p equal to 1. That p we will take as LCM and will shift it that side. So x cos alpha plus y sin alpha equal to p. This is called your normal form. This only is called as your normal form. Understood? This only is called your normal form. And when we were saying, no, suppose I have 3x plus 4 plus some 4y minus 7 equal to 0. Oh, just a second. Okay, or let's take a little simpler. Let's make it 3x minus 4y plus 7. Let's do plus 7. Huh? Okay, plus 7 equal to 0. Now, if I want to write this in intercept form, right? If I want to write this in intercept form, this normal form helps me a lot over here. This normal form only will help me. Try to use the normal form. Just think of it for a minute. Right? If I use this normal form, this is my normal form. Okay, if I use this normal form only to write it in intercept form. See, any line, just think like this. Any line, this line only will be x some cos alpha plus, or over here. This same line can be written as 3, or leave 3 also. X into something plus y into sine alpha. Wait, sorry. X cos alpha plus y sine alpha equal to some p. I can write it in this form, yes or no? Correct? Now I know that coefficient, these two coefficients, cos alpha, cos square alpha plus sine square alpha will give me 1. What do I want? I want 1 on the right hand side. To write it in intercept form, I want 1 on the right hand side. Correct? I want 1 on the right hand side. So x by p and y by p I'll do. But I want x cos square alpha plus sine square alpha to be equal. I know that this is going to be equal to 1. So this is the reason I divided by x by. So for example here, if I want, here I want, so this line if we are talking about 3x minus 4y, I want 1 this side. Right? I want 1 on the right hand side. Now try to do. Arey, what am I saying? Try to write it in intercept form, simple intercept form. Intercept form means this form, x by a plus y by b equal to 1. Try to connect this with that. Think about it. If you'll do it once, no, you'll never forget. Take a minute and try to do it. Equal to p by cos theta. A equal to p by cos theta. How beta? A equal to p by cos theta means? I'm not getting your point. Arey, just now I think one student gave the answer. No, one method is just doing this. Okay, one method is just doing this. Hitesh, this channel we have already informed, and this is said so many times that this is specifically for English. But there are so many channels for Hindi. Okay, so many channels which are teaching in Hindi, Unacademy channels itself. Please let's all of us let this channel to be in English. There are many students who face problem with Hindi and the other regional languages, so that's one thing. That's the reason. Okay, हिंदी में मुझे हिंदी आती है, right? हिंदी भी आती है, थोड़ी बहुत तमिल भी आती है, English भी आती है, but here in this channel I'm preferring to teach in English because this is for completely English speaking students and English understanding students. Okay, what was my idea, what I was trying to say, I'll just explain you that. Leave this also. There is one formula. They'll tell you that if you want to convert ax plus by plus c equal to 0 in the intercept form, what you do is that you divide a by square root of a square plus b square and b also by square root of a square plus b square and c also by square root of a square plus b square. They'll give you this directly. They'll in books or in some places they'll directly give you this formula that okay, if you want to convert it into intercept form, then do this. Just divide all the coefficient by square root of a square plus b square. That's what they'll ask you to do. But why do they ask you to do is the reason comes from the normal form. Why? Because some x into some a, if you can just create x into some a square plus y into some b square equal to 1. If you want this a square plus b square to be equal to 1, on the right hand side of intercept form, you will need 1, right? Why am I dividing? I'll tell you. That's what I'm telling Ashwath. To write any line in the intercept form, right side you will need 1. Correct? How will you get 1? You know sine square plus cos square is going to be equal to 1. Right? Here sine square plus cos square will give you equal to 1, then only this p will become equal to 1. Correct? In that case, what will you do? For this case only, how do you get? Now just simply add a plus a square plus b square whole square and b upon square root of a square plus b square whole square. You need two such numbers whose sum is equal to 1. And these are the best numbers whose sum will always be equal to 1. Just add a square by a square plus b square by a square plus b square. LCM will be a square plus b square. Numerator will also be a square plus b square. Cancelling, giving 1. Correct? Here also if cos square alpha plus sine square alpha can give you equal to 1, then directly we'll be able to convert it into intercept form. No. So my whole point is that if you want any line ax plus by plus c equal to 0 to be directly converted into intercept form, just divide by a square root of a square plus b square, right? Just do this and you'll be sorted. For example, here what we are doing, 3x plus 3x minus 4y plus 7 equal to 0. Okay, so divide this by root 25, this by root 25 and this also by root 25. This is the reason. This is the main reason. This is why they do it, because sine square alpha plus cos square alpha is ultimately giving you 1. That is the idea. It is the condition if x a square plus y b square equal to 1, then a square plus b square equal to 1. Yes, that's what I'm talking about. Okay. One mistake I'm doing. I think I've not intercept form. We are converting into normal form. My bad. Okay, I might have confused you. I'm not talking about intercept form. Intercept form, it will not directly come into intercept form. You use this only. Intercept form was this only. Normal form I'm talking about. I'll repeat myself again. If you are given with a line in general form, this is your general form. This is your general form. This you have studied in 10th class also. General form of any line. There will be a coefficient of x, there will be a coefficient of y, and there will be c, which will give you equal and equal to 0 is the general form of line. From general form, if you want to enter into normal form, this is the way. From general form to normal form. Now what will happen here? What will happen? 3 by root 25 x minus 4 by root 25 y is equal to minus 7 by root 25. Now this 3 by root 25 will become your, sorry, my bad. This 3 by root 25 will become your cos alpha, and your 4 by root 25 or minus 4 by root 25 will become your sin alpha. Why can we say that? Because now cos square alpha plus sin square alpha will give you 1. So these two values can be cos and sin. Sum of these two is giving you 1. So for moving from general form to normal form, I might be using the word intercept, but normal form. We are talking about normal form, not intercept form. Intercept form, so you can easily get, just like how I think Ashwath, you only did it, right? Just divide this 16 and reciprocal, so 16 by 3 and 4 will become the intercepts. That was the simple idea. Okay, here also same line, 3x minus 4y plus 7. Suppose 3x minus 4y plus 7. If you want to enter into intercept form, many times you'll get this need. So simply just take 3x minus 4y equal to 1 and 7 you get divided, and then reciprocal this 7. This is your intercept form. The two intercepts will be 7 by 3 and 7 by 4. Okay, that was okay. Normal form equation is to find normal of the given line. Yes, normal of the given line or inclination of the normal with the given line. Sometimes in the problem beta, they'll give you directly this thing. They'll give you only this thing, that the line, there is a line which is perpendicular from origin, or they'll give you that distance of this line from the origin, perpendicular distance of this line from the origin is 7 units, and the inclination of the inclination or the angle which the normal line, which the perpendicular line is making with the x-axis will also be given to you. So direct you will be able to apply the answer. I'll try to find some question related to it. Just a minute, so that you'll get practice here itself. Question. Sorry. Simple. Just a minute. So what question we can take over here? I'll just dictate you the question. Suppose find the equation of a line which is at perpendicular distance of 2 units from origin and angle made by perpendicular with the positive axis is 150 degree. This is a question of mains only. This is a question of mains only. Okay, direct questions will come from normal form. Okay, direct questions can come from normal form. Remember it. I'm glad you said that, just a learner. Direct questions can come from normal form, right? They'll simply give you distance, find the equation of line which is at distance of 2 units from origin and the perpendicular, they'll give you the twisted question, right? They'll give you the twisted question and the angle made by perpendicular to the line is 150 degrees, something like this. Something like this is the question. I think I'm reading correct. With the positive direction of x-axis is also written. But basically what is it? It is the question of normal. They are talking about a line which is making not this. They are talking about a line which is this, right? This angle is given 150 degree, and whenever in entire straight lines, in entire coordinate we are talking about, whenever we are talking about angle, we are taking angle from the positive direction of x-axis. Okay, so they are talking about this thing, nothing else. Okay, now in this case what will happen? Same thing you are going to do, nothing different, right? Your alpha will become, how do you write the equation? X cos alpha plus y sin alpha is equal to P. P is given to you. What is P? Perpendicular distance 2. This becomes 2. X cos alpha becomes cos 150. Sin alpha becomes sin 150. You directly put sin 150 cos 150, or you can solve it like pi minus 30 and pi minus 30 and pi minus 30, no? Or you find this angle, and in that case you make the equation. Right? Both the ways are there. If you find this angle also, same type of equation will come. Right? Y root 3 minus x root 3 is equal to 4. Great. Yeah, I think, I don't know the answer, but something like this. It should come as root 3. Kitna? How much are you saying? Y root 3. No, see, cos 150 will become minus cos 30. Sin 150 will become sin 30. So minus cos 30 means minus root 3 by 2. Minus of, this will become, minus x root 3 by 2 plus sin 150, no? So y sin 30, y into 1, y by 2 equal to 2. That's it. So it will become minus root 3x plus y equal to 4. Right? Minus root 3x plus y equal to 4. The final result will be. But how important is our normal form also? Now let's summarize. We have got into too much depth. Let's just summarize once. What did we learn? Slope of straight line we understand now. What do we mean by slope of straight line? It is always taken in anti-clockwise sense. Take it from the positive direction of x-axis. Simply, tan theta slope will always lie between pi and 0. It cannot be equal to pi because same answer will come for 0 and pi. So that is why greater than equal to 0 and less than pi is written. Okay. Now what else did we learn? This thing we learned, slope is defined as y2 minus y1 upon x2 minus x1 if we are given with 2 points. Right? Always tan theta is always, if tan theta is greater than 0, your line will be like this. If your slope is positive, this also we learned. If your slope is positive, line will be in the first quadrant. If your slope is negative, line will be in the second quadrant. This also we saw. Okay, we have learned one more thing, same intercept. This is one important concept on which sometimes questions are asked. They'll tell you same intercept or equal intercepts. Same intercept and equal intercept are the two different things. For example, over here, same intercept is written. Same intercept means if this is 2, 0, this is going to be 0, 2. Okay. If this is 0, minus 2, then this will be minus 2, 0. This is called same intercept. Minus 2, 2, 2. Same intercept. You can easily find the equation. Now in this case, when you have same intercept, if you find the slope over here, 0 minus 2 divided by 2 minus 0 will come minus 1. Here also, minus 2 minus 0 divided by 0 minus minus 2, slope will be minus 1. In these cases, when same intercept is there, that time always, in any case, if same intercept is there, slope will be equal to minus 1. Sometimes they'll say equal length. So pay attention in the question when you are solving. Equal length of intercept is different. Equal length of intercept means this is 2, 0, this is 2, 0. Okay, in this case also this length and this length is equal. Okay, this is 0, minus 2, right? This is minus 2, 0. In this case also length of intercept, here also 2 is the length, here also 2 is the length. In this case also length is 2, length is 2. But length of intercept is same in this case also. But intercepts are 0, 2 and here the intercept is minus 2, 0. In this case also this length and this length We are talking about length. Pay attention. We are talking about length. In this case also, this length and this length is equal only, same only. Getting my point? But right, in this case also, intercept is different, but length is same. So pay attention. Same length or equal length. They are saying same intercepts or intercepts of equal length. Two different concepts. If they are saying same intercepts, then you can be sure that slope is going to be equal to -1. But if they are talking about equal length of intercepts, then you cannot be sure. Then your slope can be either 1 or -1. In these cases, your slope will be -1. But in these two cases, slope will be equal to 1. For example, this is 2, 0 and this is 0, -2. Here also, this length is 2. This length is 2. But if you find the slope, just try finding -2 -0 divided by 0 -2. What is the slope? -2 upon -2. That means +1. In this case, slope is positive. In this case also, slope will come out to be positive. But in these two cases, slope can be negative. So if they are saying equal length of intercepts, then you can not be sure. You have to say if equal length of intercepts, that means m can be +1 or -1. Both the cases you'll have to consider in that scenario. Okay, ji? If a line is equally inclined to axis, equally inclined also same thing. Acha, equally inclined means what? Just think about it. Equally inclined means, suppose this is your x-axis, right? Equally inclined, very important thing. This is different. This is different. Wait, this is different. This is a bit different. This means this case. Equally inclined to the axis, that means this angle and this angle are same. This is θ1, this is θ1. In that case also your slope will be either 1 or -1. But if I say that it's here, it is talking about to the axes, that means both the axes, y and x, both. Here it is talking about y and x both. This is pi minus θ1. This will become, this will also become pi minus θ1. Correct? But this does not mean slope is equal to 1 or -1. This is a different case. This is a different case. When they are talking about equally inclined to both the axes, this is a plural term. That means x and y both. In this case, you cannot make out any condition. But one important condition is there, that suppose if it says that two lines are there, who have the same, if two lines are there who have the same slope or equal inclination, not same slope, I'll write it over here, equally inclined to x-axis. If they give you a question, or if this line is written, that there are two lines who are equally inclined to x-axis. In this case, there is an important conclusion which will come. So equally inclined, that means this is θ1, this is θ2, let's say. Although we should take from the positive side. But here, let's suppose this is θ1, this is θ2. Now, this will be what? This will be alpha, right? This will be alpha. Correct? If this will be alpha, what will be this? Pi minus θ1 plus θ2. What will be the condition? Tan alpha will be the slope of this m. This will be, let's say, m2. But slope of this will be tan θ2. Not, why am I putting equal to? Right? Slope of this line will be tan θ2. No problem. Tan alpha is okay. Now θ2, if you if you know the property, alpha is going to be equal to pi minus theta 1 plus theta 2. Pi alpha will be equal to exterior angle equal to sum of two interior angles. That means pi minus theta 1 plus theta 2, correct, plus theta 2, correct. So alpha will be equal to pi minus theta 2 and plus theta 2 gone, pi minus theta 1, right. This again will come out to be, this alpha will come out to be pi minus theta 1. We already knew also, not a problem. And what will this condition give us? Tan of pi minus theta 1 plus tan of tan of theta 1. What will this give us? This will just simply give us m1 plus m2 equal to 0. So if there are two lines who are equally inclined to x-axis, in that case sum of their slopes will come out to be equal to 0. In that case sum of their slopes will come out to be equal to 0. You can also note or write this down somewhere. Equally inclined means, or by this way, equally inclined means this will also become theta 1. No, that's why I'm saying. I hope you have understood. You have got this down, right? This theta 2, theta 1, and this will also become theta 1, equally inclined. So pi minus theta 1 is this. This is also pi, theta 1 only. Or just simply, you can understand it like this also. Equal, just remember this. Equally inclined to x-axis. There is no need to write theta 2 also. Equally inclined to x-axis means this is theta 1, this is also theta 1. Simply this thing. Okay. Or not theta 1 also, just write theta only. Why write theta 1, theta 1? In this case, m1 plus m2 will come out to be equal to 0. So suppose you can think it like this. Suppose this is your m1. So m1 will be what? Tan of theta. And this is your m2. Can I also write m2 is also tan of theta? No. No problem, Ashwat. Can I say m2 is also theta? No. M2 is this angle. So m2 is tan of pi minus theta. Okay. Getting my point? m2 is tan of pi minus theta, which will be what? m2 will be nothing but minus tan theta. This is why we can simply say m1 plus m2 will be equal to 0. And this will happen only in one condition, if two lines are equally inclined to x-axis. Very important. Sometimes in questions they'll give you this, but this will not strike you. But if you understand and draw this and do this on your own once, this will easily strike you. This will easily strike you. Okay ji, now slope is clear till here. Horizontal line, vertical line, these things, everything was clear. This and all we have already understood. Slope intercept form, we have done that. We saw it very in detail. We have discussed. In detail we have discussed so that you get the idea, you understand, you propagate your idea towards solution of a problem. Okay, so that you can you take least amount of time to start with the problem and reach towards its solution very fast. If you can if you do these things on your own, visualize these things on your own in the way which we have learned, then you'll be able to do it very easily. Otherwise it is definitely difficult. Okay, 2-point form. This also we saw. Intercept form, x by a plus y by b equal to 1. Normal form we saw. One more form is left. Right, normal form was also understood, right? Normal form was also understood. Acha, one more case was of normal form. This case, right? This case. But if line is this, normal is over here. In this case, You remember how to do. In this case, you'll do nothing but if this angle is given to you, this alpha is given to you. If this is alpha, then your alpha is pi by 2 plus. You'll adjust your angle according to it, right? Pi by 2 plus this angle. You'll adjust. You're right. You'll take for this one also equation will be same. X cos alpha plus y sin alpha equal to P. For this one also equation will be same only. There will be no difference in the equation. If line is this, don't think, sir, will there be any negative or any positive? Just remember this alpha is from the positive direction of x-axis. Just remember that much. This alpha you are taking from the positive direction of x-axis. If line comes like this, it is not applicable only for this case. For every case, same thing is correct, right? For this case also, if this is P, here also equation will be same, but alpha will be like this. Here alpha can be between 0 to 360. Here this angle alpha can be between 0 to 360. No problem, Ramasamy. No problem, Ashok. Just remember, alpha you have to take from the positive direction of x-axis. Whatever is the case, don't be afraid. Sometimes students get confused that, sir, no, line was not, this case was not there. Alpha was getting more than 90 or something like that. But you remember, alpha can be anything between 0 to 360 over here. It's not like slope. Theta can be only from 0 to 30. But this line can rotate 360 degrees. For finding cos alpha and sin alpha, for finding cos and sine of alpha, you'll need a little bit of trigonometry, compound angles, that's it, nothing problem, no problem. One more form I was talking about. Now sometimes what they'll say that, okay, that there is this point, some point will be given to you, x comma, suppose x comma y point is given to you. Now they'll say that you find a form, they'll ask you to find another point. They'll ask you to find another point which is at a distance of d or distance of r from this point. They'll ask you that there is a line how will I give you the question? They'll tell you that find a point which is at 3 units from 2, 3. Or find a point which is at 5 units from 2, 3. Let's say this point is some h, k. Okay, this is also one condition. They'll ask you that, okay, find a point which is at 5 units from h, k, or or some r units. If we're taking in generalized form, they'll ask you what are the coordinates of the point which is at r units from x, y. Very simple. Very simple. How simple, sir? How simple? And they'll also tell you, they'll also give you the slope or something, some more information they'll give you. They'll not simply say that 5 units. 5 units can be anywhere, right? Now voice is there. Now voice is there. Let me check यार. Voice का problem कैसे हो गया? Hello. Hey voice, okay, coming, no problem, right? All right, what I'm saying, just think, how will you find this? You know the formula, you know what type of thing, also what type of form it is, but right now I'm asking you, think of it as a problem. I'm telling you from 2,3, how will you find the point which is at 5 units in theta direction? Theta is the angle from the horizontal axis. I'll just be back in a minute. Please try. Anji, what's happening? Nobody's. I'm asking. Simple problem, no? Simple trigonometry only here you have to use. Are bhai, we know that if I want to find this point, okay, I have theta, right? I have theta. So this point I want. What will I do? This distance I'll find. This is theta. Sine of theta, cos of theta will be base upon hypotenuse. What will be base? What will be base? This thing will become 5 cos theta. Correct? 5 cos theta. This will become 5 cos theta. And here, this height will become perpendicular upon hypotenuse, so perpendicular will become 5 sin theta. Correct? Now coordinates of this point. This point is 5 cos theta ahead of 2. So x coordinate will become 2 plus 5 cos theta. Try understanding. Okay? 2 plus 5 cos theta. And K point, this K point is 5 sin theta above 3. So this will become 3 plus 5 sin theta. Okay. This is important. So we can generally define it. So if a point is r distance ahead or behind. Acha, same thing could be like this also. Same thing could be over here also. Just think over here. 5 units. This point, let's say h1 comma k1. This point is also 5 units at a 5 unit distance and same angle theta. Same angle theta. Here also this is also making same angle theta. Right? Theta inclined. So but this point will become 2 minus 5 cos theta comma 3 minus 5 sin theta. Correct? There can be two possibilities. In this direction, there can be a point at 5 units, and this direction also there can be a point at 5 units. Both are inclined to theta degrees, or both are inclined with theta. So that is why here we'll generalize this thing. We'll generalize this case now. Achha, this point which is at r units, from x comma y, and inclination of this point is same as x comma y, which is theta. What will be this point? Simply x plus r cos theta, comma y plus r sin theta. As simple as that. As simple as that. So we can, one more way is there to think about this. Okay, suppose we want a point. Now x1 comma y1 is the point which is given to us, and now we are generalizing. We want a point which is x comma y, and it is at r distance from x1 comma y1. Okay, which is at r distance from x1 comma y1, and its inclination or its angle with the x-axis is given as theta. So now what will be the coordinates of x and y? X will become x1 plus r cos theta, correct? Y will become y1 plus r sin theta. Simple thing. What else can we say? We can make an equation. This the parametric form which we call, that equation is written like this: x minus x1 upon r equal to y minus y1 upon r. Oh, sorry, wrong I'm writing. X minus x1 upon cos theta will be equal to y minus y1 upon sin theta, and this thing will be equal to r. I think all of you are understanding. Okay, I can see good response in the chat as well. Amazing. X minus x1 upon cos theta equal to y minus y1 upon sin theta equal to r. This is this way of writing a line which is connecting two points which are at r distance and an inclination of theta is called as parametric form. Is called as parametric form. Nothing else. Alright, ji. Note this down. Now, where did we start from? We started from the different points inside the triangle. We started from different points inside the triangle. That was the objective. For example, let's talk about centroid only. Right? We have learned all the forms. I'll just show you the parametric form also. This is the parametric form. Right? General form we have already discussed, ax plus by plus c equal to 0. Okay, now next thing, what was the main motive? Sir, main motive was this, that we have 3 points in a plane, connecting 3 points with lines, right? Let's say this is x1 y1, this is x2 y2, and this is x3 y3. We started from this, but we got lost in the way. We actually got lost in the way. Now, this was the main problem, right? When we started the chapter, we started from this particular thing, that bhai, x1 y1 x2 y2 x3 y3, 3 points in a plane, when we are connecting them, it is making a triangle. What were we trying to do? We were trying to find some points inside the triangle, special points. For example, the point where all the medians will intersect will be called as centroid. Suppose we want to find the centroid. Here we started. There, from here only the idea of entire straight lines or entire coordinate geometry started. But we lost in the way. We did a lot of other research in order to find this. Now, but still, we have no idea how to find this. Acha, before this problem, before this, one more thing comes in our mind. Sir, what if this point lies outside the triangle? What if the point lies outside the triangle? Correct. It is a possibility. Point might lie outside the triangle also. How do we check that? For that, very important concept for advanced, especially for advanced, this concept will be very, very useful. Okay, ji. Now suppose, what can be the conditions for a point? 2 points. What can be the conditions for 2 points? I'll come back to this. Before this, let's discuss this. What can be the condition for any 2 points? Either they can be on the same side of the line, or they can be on the different side of the line. Only 2 possibilities are there. Or both the points can be on the line. 3 possibilities. Either opposite side, same side, or on the line. How do we know whether 2 points are on the same side of line or not? Or opposite side or on the line? Achha, on the line, so we can easily understand. If both the points are on the line, then they'll satisfy the equation of the line. Right? They'll simply satisfy the equation of the line. But if they are on the same side of the line, if they are on the same side of the line or opposite side, then what will happen? How do we think about this? How do we think about this? Achha, when I'm saying that there is a point which is above the line, or let's say left side of the line. Okay, what does it actually mean? What does it actually mean? This line is ax plus by plus c equal to 0. This line is nothing but ax plus by plus c equal to 0. Okay, this point is x1 comma y1, let's say. Okay, or x comma y also is fine, but let's say x1 comma y1. Achha, if this point is above this line, I'm not calling right, left, just saying above this line. Above this line, what does that mean? What does that mean? Will it always be above the line? No. Because if I extend this line till here, this point will come below the line. Only for this particular part of line we are talking about. When we are talking about a point which is on which side of the line, above or lower, then that time we are only talking about some part of the line, not the entire line. Okay, so that will simply mean that if this is above, this means that at perpendicularly down, somewhere at the same distance down, this point will be x1 only. What will be this point? What will be the coordinate, or what will be the y coordinate of this point? This point. X coordinate will be x1 only, because this is vertically down. Y coordinate will be what? Just find it from here. Put x as x1. So y coordinate will become minus c minus a x1 divided by b. Correct? Now what do we know? What information do we have from here? Achha, from here can we simply say that y1 will be greater than this? This point is above, na? So y coordinate will be greater than y coordinate of this point. Y coordinate of this point will be greater than y coordinate of this point. Okay. Okay, I'll do that. Okay, keep listening. Okay, keep listening. We'll come to this part. Before that, try to understand the idea behind it. How are we actually building the idea behind it? Okay, that is very important. y1 will be greater than this, yes or no? Listen to me, just keep listening to me. y1 will be greater than this. Can I say y1, or instead of taking y1 x1, just take xy? Better xy, so that you'll understand in a better way. simply xy will be fine. X and here also x. Okay, can we say now, can I simply say y will be greater than minus of ax plus c divided by b? Can I say that? This is correct or not? This is correct to say. Solve this. If we solve this, what we'll get? By plus ax plus c is greater than 0. Then only we can say, right, that this point x1 comma y1 which we took, right now we are saying x, we generalized it to x and y, but if this point was something else, suppose 2 comma 3, suppose this point was 2 comma 3 and this was some line, what condition are we getting? If this point is on one side, above or below, let's say above, we can simply say, right, ax1 plus by1 plus c will be greater than 0. And similarly, if this point was x2 y2 and this was below the line, for this what we will get? This y2 will be smaller than this, y2 will be smaller than this. In this case, what we will get? In this case, what are we getting? For this point, what we will get? ax2 plus by2 plus c will be less than 0. If you can understand this, you will understand everything. You will understand this thing very easily. This condition is important. How did we approach towards it? First we saw that y is above. So that means y coordinate of this point will be greater than y coordinate of vertically down point on this line. And below means y coordinate of this point will be smaller than vertically up point on this line. That's how we reach to this. Now, one is positive, one is negative. One is positive, one is giving you positive, one is giving you negative. Now, suppose the points are over here. x1, y1 is here and x2, y2 is also over here. Okay, this is the condition. In this case, what we will get? ax1 plus by1 plus c will come out to be greater than 0. ax1 plus by1, ax2 plus by2 plus c. C, are we doing correctly? C1, C2, I think we should use. No, C, same C. C is same, no, line is same. This will also come greater than 0. In this case, if both x1, y1 and x2, y2 were on this side, right, were on this side. In this case, what you will get? ax1 plus by1 plus c less than 0 and ax2 plus by2 plus c, this will also be less than 0. Correct? In both the cases, product of these two will be positive. In this case also, negative will become positive, positive into positive will become positive. So if I am checking 2 points which are x1, y1, in this case what will happen? Let's discuss this case also. Right? In this case what will happen? When we'll put x1, so ax1 plus by1 plus c will be greater than 0 and ax2 plus by2 plus c will come out to be less than 0. Product of these two will become less than 0. Positive into negative or negative into positive. Less than 0. No, Gautam. Yeah, from 0 basics, definitely yes. I told you, right? It's never late. It's never late. It's never late. You can always do that. There are crash courses going on many Unacademy channels. And we have also covered a lot of topics. If you go to one shots one by one, learn from the basics and solve some PYQs. Last 6-7 years PYQs also, if you can solve, no, I can guarantee you can clear from 99 percentile. Okay. Understood? Very simple thing. Product you have to look at. So if ax1 plus by1 plus c multiplied with ax2 plus by2 plus c is greater than 0 for a line, ax plus by plus c If this is greater than 0, that means points are on same side. This means same side. Very important concept. Many questions are asked from this concept only, and today we are doing concepts. It's not theory. Theory can be taught very easily. Conditions, conditions, conditions. Here we are building the concept, so pay attention. Okay, theory can be taught very easily. It's not difficult to teach the theory. There are certain formulas, there are certain formulas, that's it. Some 6-7 formats to write the equation, some 5-6 formulas, and then some more 3-4 more formulas, family of lines, angle, bisector, everything can be taught very easily. With questions also you'll understand. But this is important for problem solving. That's why we are taking concept classes. Okay, how to think is important over here. Very, very important. Trust me. Same side means product of these two will come greater than 0. Correct? If this is less than 0, then otherwise means otherwise different side. If this product comes less than 0, that means points are on either sides, opposite sides of the line. This is how we can check whether our point will lie inside or not. Okay, with respect, how will we check? Again, how will we check? We'll check this point with respect to this line and with respect to this line. If it is giving same sign, that means it is between these two lines. Then we'll do the same thing for this line and this line. If it is giving same sign, that means it is inside the triangle. Then we can confirm. Sign will help us. Suppose this point is some h comma k, right? And this is ax, this is some line, this is some line, this is some line. We satisfy this point in the 3 lines, take the products, check the sign, and that's how we make sure that where does it lie. Okay, sir, all this is fine, but you are still not coming to the main topic which you were talking about. Correct? We have not come to the main topic, no? Till now. Have we? Okay, sir. Fine. This thing is clear, that how to check the point whether it will lie inside or outside. But still, for this point, what do I need? I need something else also. Acha, if I can find the angle, now my main objective is to find the distance. What I'm trying to do is this h comma k, which we are calling the centroid. I know that it will pass through the median from the vertices, will pass through this point, all the 3 medians, right? That I know. All the 3 medians will pass through this point. Still, how will I get to this point? Acha, one more property, geometry I can use, 2, 1. This is 2, 1, that I can use, not a problem. One more thing I need, right? What do I need? I need the angle. I need the angle between the 2 lines. Do I need it or not? Think about it. Do I need it or not? Here, do I need it or not? No, no need. Okay. Acha, one more information I know. Basic geometry I know. Okay, I don't know coordinate geometry, but basic geometry I know. I know median, centroid bisects this point in 2, 1. Okay, that we have learned. And this side in 1, 1. Median means dividing the opposite side in equal ratio. This and this will be equal. Okay. But still, how will I find, if I have the coordinates of this point, then I can find the coordinates of this point. If I have the coordinates of this point, then I can find the coordinates of this point, but I still need the coordinates of this point. For that, I know you know the section formula, but still realize the section formula once again. Okay, how sir, how to realize? Acha, x1 comma y1 is 1 point, x2 or here we have x2, y2, x3, y3, right? This is 1 point which is x2 comma y2, and this is 1 point which is x3 comma y3. See, understand from the very basics, no problem in that. No problem in that. Let's say the ratio, here the ratio is 1, 1, but let's say here the ratio is m, n. m comma n, and you need the coordinates of this point. You need the coordinates of this point. How will you do that? How will you do that? Simple similar triangles. This triangle and this triangle are going to be similar. Why, sir? This is 90. This is 90. This angle are equal. By AA similarity, we can say that these two triangles are going to be similar. If these are similar, let's say this point is my x comma y. Okay, this point is my x comma y, midpoint. What will be the length of this line? This line? This distance. What will be this distance? Let me change the color. I know it is a bit short. What will be this distance? Sir, it will be nothing but y3 minus y. What will be this distance? It will be nothing but x3 minus x. Okay. Similarly, this distance will be nothing but y minus y2. And this distance will be nothing but x minus x2. By similarity of triangles, I can say y3 minus y upon y minus y2 will be this divided by this will be equal to this divided by this. So x3 minus x upon x minus x2. And these two will be equal to this divided by this. That means m by n. This is how section formula comes. We have by-hearted it. We have learned it, right? We have learned it directly, but this is how it will be updated to you. It will be updated to you. Don't worry. Okay. It will be updated to you. Got the idea? Similar triangles is the root method to find the section formula. And when we'll solve this, we'll simply get x is equal to mx1 plus nx2 divided by m plus n, and y is nothing but my1 plus ny2 divided by m plus n. Okay, simple idea. This is how. So here, although I was getting a intuition that this is going to be x2 plus x3 by 2, right? M and n both are 1, so this will become x2 plus x3 by 2 comma y2 plus y3 divided by 2. Correct? This will be the point. Okay. Okay. Now this point divides this median in 2:1. And here I'll again apply the section formula. What will I get? 2 times of x2 plus x3 divided by 2 plus 1 time of x1 divided by 2 plus 1. This will be my x coordinate, and similarly the y coordinate. Similarly the y coordinate divided by 2 plus 1. Right? 2 into y2 plus y3 plus y1 divided by 2 plus 1. Correct? This 2 will get cancelled, and what will I get? Centroid I'll get. What will be my centroid? x1 plus x2 plus x3 divided by 3 comma y1 plus y2 plus y3 divided by 3. This is how I can easily get the centroid. Amazing, right? We have learned all these formulas, but we do not, and it is very important to realize them from the depth of solving, because this is not concept, this is actually problem solving. This, if you do know, why do they give, you must have seen so many proofs in NCERT. You must have seen so many proofs taught in theory. If you are going to any good classes, no, they'll always pay attention on the proofs. Why are there proofs? Proofs are there to build the fundamental, to build the basics, to build the problem solving. Are formula anybody can tell. 8th class student also, if you make him mug up the formula and just tell him how to apply the formula, he can also apply in simple questions. But JEE is not going to give you direct formula based question. They'll give it something. They'll give you something where these things are going to be applied. For example, external bisection, suppose. Okay, this is some point A, this is some point B, this is some point C. C is externally bisecting A and B in 2:1, let's say m ratio n. This is m this time and this is n. What will be the coordinates of B? External bisection. Same which we did no just now. Similarity. Same if you'll apply, you'll get the same answer. But for here, from here, if you want to apply it, just remember that x coordinate will be mx2 minus nx1 divided by m plus n. Okay. Sorry, m minus n will come. M minus n will come. Right? And y coordinate will be my2 minus n y1 divided by m minus n. This thing only will come. Okay. Or if you want to remember it with the normal formula, suppose this is m, this is a, this was b. Where was c in the normal formula? Normal formula which we learned just now. This was your m, this was your n. Now what you did, you took this part. In some books, in some places, it is suggested to learn it like this. You took this part and flipped it over this side, right? You took this part and what you did, you flipped it over this side. So your C came over here. What was M? Distance between A and C. So this became N. What was N? Distance between C and B. But because you flipped, plus N will become minus N now. Same formula you are applying, right? M, this is your M, right? M into x1 minus n into x2 divided by m minus n, and similar for y. This is how some students, some people remember, or some people write it like this or remember it like this. No need to remember two different formulas. In same formula only, you are just flipping this over this side. Okay. External bisection idea also is like this only. Okay. So we reached, where did we, till where did we reach? Acha, centroid we have realized. Centroid we have realized. Now what happens? Now we have done a lot of things. We started from very basics, but we have done a lot of things. Now to find the other points like orthocenter. Like orthocenter, what will we need? We'll need the angle between the lines. So now we'll see that how can we find the angle between the lines. Important, right? How can we find the angle between two lines? Suppose I have two lines. These are my two lines. How can I find the angle between these two lines? And mostly the angle which we are interested in during problems, especially of JEE, the angle which we are interested in is this one, theta. Okay. Acha, this is my line 1, this is M1. Let's say this is M2. This slope is M2. Okay. M1 means this angle I'll need, let's say this angle is alpha and this angle is beta. Okay. Let's say this angle is alpha, this angle is beta. So the slope M2 is equal to tan beta and M1 is equal to tan alpha. Okay. M2 is equal to that. I have a problem that I want to find this angle. I want to know some information about this angle. Either this angle or sine cos tan of this angle. That's what I need. Okay. Okay ji. Angle between two lines will be found like this only, no? What information will I have? I'll have these angles. I'll have slopes of the lines. Equations of the lines will give me slopes otherwise. Okay. Equation of, right now we'll cover the chapters of coordinate geometry first. Straight lines is the most basic of it. Then circles and conic sections. In between we'll also try to cover pair of straight lines. Although pair of straight lines you guys already know from 10th class. Although, but still, if you want, we'll cover some part of that also in the way, during the way. This part is clear? Okay, so what were we saying? M2 is equal to tan, M2 will be equal to tan beta and M1 will be equal to tan alpha. That we know. What else do we know? We know exterior angle property, basic geometry we know. We know beta. We know beta is equal to theta plus alpha. Beta equal to theta plus alpha, that also we know. Alright. What else do we know? Achha, if we have theta, pi minus theta won't be a problem. So even if you are thinking, sir, what about this angle? There can be 4 angles. This is also an angle. What about this? If you have theta, then you can do pi minus theta. So worry about one angle, right? That's why. Beta is equal to theta plus alpha. Understood? Now take tan on both the sides. Tan beta is equal to tan theta plus alpha, tan alpha. But. What did we want? We want theta, no? So theta is equal to beta minus alpha. Correct? Beta is equal to theta is equal to beta minus alpha. We are interested in theta only. Now take tan. Tan theta is equal to tan beta minus alpha. Problem solved. What is this? This side what do we have? Tan beta minus tan alpha. Tan A minus B. Tan A minus tan B upon 1 plus tan A tan B. Tan beta minus tan alpha upon 1 plus tan beta tan alpha. What is this? Tan beta is M2. Tan beta is M2. Tan alpha is M1 divided by 1 plus M1 M2. This is my tan theta. This is my tan theta. Tan theta is not the slope over here of anything. Tan theta is just tan of an angle theta. The angle between these two lines. This is what we get. Great. Very nice. Now sir, specific conditions. Sir, if the lines are parallel, they are not intersecting only. If the lines are parallel, that means angle between them is equal to 0. Angle between them is equal to 0. That means this thing is equal to 0. Right? Angle between tan 0 is 0, right? So tan 0 is 0. So this thing is equal to 0. In this case, what will we have? M1 equal to M2. Why? Because numerator should be 0. For this to be 0, numerator should be 0. Denominator cannot be 0. Numerator should be 0. If numerator is 0, M2 minus M1 is equal to 0. That means M1 is equal to M2. If lines are perpendicular, sir, then what do we do? This is M1, this is M2. If they are perpendicular, that means tan 90. Tan 90 is not defined, or we can say infinity. Not defined is better. When will it become not defined? When denominator will become 0. Denominator becomes 0, that means 1 plus M1 M2 becomes 0. That means M1 M2 becomes equal to minus 1. Amazing. Right? That means M1 M2 becomes equal to minus 1. This is how learn each and every subtopic of every chapter. Then you'll get mastery. Now here also some more things we can discuss. Sir, suppose sir, AX plus BY plus C equal to 0 is a line. I want a line perpendicular to this line. I want a line perpendicular to this line. What should I do, sir? Acha, what is the slope over here? What is the slope over here? Slope over here, sir, I'll shift AX and C on that side. So it will become Y equal to A by B. Y equal to minus A by B minus C by B. Minus A by BX minus C by B. So sir, slope over here is minus A by B. Okay. Now if I want a perpendicular line, what should be the slope? Slope should be equal to B by A. Then only minus A by B and B by A will multiply together and become minus 1. I want the slope to be B by A. So what should I do? I'll just simply write AX minus BY plus C equal to 0. Only this line is perpendicular, sir. No. Every line, all these lines are perpendicular. So this is one. This more AX minus BY plus D equal to 0 is also perpendicular to this line. Okay. ax minus by plus e is also perpendicular. Minus ax plus by plus e is equal to 0. This is also perpendicular. Slope of this is also a by b. Sorry, b by a. What did I do? A by b it will come. No. Something wrong we are doing, kya? Wait. Oi. Yeah, so wrong. This is wrong. Slope of these lines is not b by a. If I want to make a perpendicular line, ax minus by bx minus ay. Change the coefficients also. Bx minus ay plus d equal to 0. What will be the slope of this line? B by a will be the slope of this line. Right? Check once. B by a will be the slope of this line. A bhai kya kar raha hu? B by a will be the slope of this line. Correct? Or what I can do, minus bx plus ay plus e equal to 0. This will be the slope of this line. Why am I changing this coefficient, this constant? Because all these lines are perpendicular, right? Different lines parallel to each other will be made by just changing the constant. Minus bx plus ay equal plus e equal to 0. The slope of this one will also be b by a. So all those lines whose slopes are b by a will be just perpendicular to this line. Simple question if we take over here. Sir, what will be you want a line 3x plus 4y plus 1 equal to 0. Sir, I want a line which should be perpendicular to this line. Now don't write the slope and then make the product minus 1. Simply do one thing, no? Simply do one thing. 4x minus 3y plus 2 equal to 0. This is also perpendicular to this. Slope over here is minus 3 by 4. Slope over here is 4 by 3. Product will be equal to minus 1. Simple thing. Okay. You want a line perpendicular to this line, you can keep the coefficients, you can keep the constant same. That is also not a problem. Right? Just keep the constant same. One perpendicular line you will get, which will pass through that point also, point of intersection also. Point of intersection will be different in every case. Right? In some specific case, if you want something like this, then this is also perpendicular. You keep changing this constant, but these things are same. Then you are getting perpendicular lines also. One more thing you can do, minus 4x plus 3y plus 1 equal to 0. This is also perpendicular. Slope of this also is 4 by 3. 4 by 3. 4 by 3. This one's slope is minus 3 by 4. You want the slopes to be 4 by 3. This is also 4 by 3. Slopes is 4 by 3. Then only 4 by 3 into minus 3 by 4 will make minus 1. Na? So this is how you can approach. Centroid of the median was clear, right? There was no problem in that. Now to find, this was one thing which I needed to find the other points. This was one thing. Very good. YTGT, great. Amazing. Okay, I'll take just 5 minutes break. You guys can revise. You can also take a break if you want. If anybody is sitting from the starting, just take a small break and we'll be back. Okay, we'll be back very soon. For PPT, no, Ashwath, I've already informed, right? In the next session, I'll be solving all the PYQs from 2002 to 2024. At least 2023, 24, till 2024. So as many as you can solve. They'll be somewhere around 160 or 170. Okay, somewhere around 160, 170 PYQs will be there in all sets from 2002 to 2024. Solve as many as you can. That I will say. As many as you can. Okay. So we'll discuss all of them. I'll try to arrange them in a good sequence and we'll discuss all of them. Okay. This was it. Let's move ahead. Now what? Sir, now what? What is remaining? Some more things are remaining about straight lines. What all did we do? We learned about coordinate system, equations of line, different forms of equations of line. Just now we did angle between the line. Before that we found one point. Section formula we did. One point we found. Right? Centroid of the triangle connecting 3 points. Now let's move to another point. One more point was there. No? Some more points can be there. We are not still. We didn't want. Did we only want to find centroid? We are not bothered about the other points. We also did how to know about the position of point with respect to a line, up or down or which side. Okay, all these things we saw. Now some other points. Orthocenter. Orthocenter means intersection of all the altitudes. Intersection of the altitudes. Or incenter, right? Incenter also we can find. Now we can actually move towards incenter. What is incenter? Incenter has two definitions. One is that it is the center of the circle inscribed inside the triangle. Center of the circle inscribed inside the triangle gives one more idea. If you are familiar with circle properties, then you can see from one point, if we throw two tangents on the circle, then the line connecting the point and the center of the circle will be the angle bisector of this angle. So incenter, this is incenter. Okay. Incenter. One more thing about incenter is that it will be the intersection point of all the three angle bisectors. It will be the intersection of all the three angle bisectors. And why did we learn about finding the angle between the lines? For this thing only. If we can find the angle between the lines, this won't be tough for us. Finding this point will not be tough for us. Can you think of a way? Can you think of the direction or approach towards this? Okay, let's talk about this thing first. Okay, let's talk instead of this, let's talk about this point. Although this can be directly given as formula, right? But I'll tell you how to think in this direction. Acha, one property which is very useful in many questions is the property of angle bisector. Suppose this is the angle bisector. Okay, let's say this is A, this is B, this is C. The side opposite to angle A is A, side opposite to angle B is B, small b, and side opposite to angle C is small c. Okay. You have seen the, what do we call it, protractor, and one more thing, divider comes, right? Divider. Do you know what is something special about the divider? Divider looks something like this. Sir, where are you bringing divider and all? Arey, listen, no. Listen, the more you take interest in the subject, no, better your understanding will be, and you can reach depths in that subject. Now you have seen divider. You have seen divider. When you open the divider, what is good about, what is special about it? What is special about it? You know, when you open the divider, no, these two sides of divider are equal, and when you open it, the amount which you are opening it for, it will keep on dividing it into equal lengths. It will keep on dividing it into equal lengths. Suppose you have opened it for 3 centimeter, then there will be a point, there will be a center point where this will be 1.5, this will be 1.5. But majorly what I'm saying is, this example, okay, you can, if you understood, good. Otherwise, majorly what I'm saying is that when you are opening an angle, right? Now, angle is not always divider. It can be like this also. It can be like this also. This is A, this is B, let's say. Or in this case, we are seeing, right? In this case, we are seeing, so let's say this is C, this is D, or this is B. Okay, this is C, this is B. The ratio of C by B, when you draw the angle bisector, if you'll draw the angle bisector, this is a property also, basic property in geometry. The angle bisector, where it intersects the opposite side, will divide the side into same ratio, C by B only. Will divide this side into same ratio. This ratio is C by B, so this ratio will also be C by B. This is one very important property of angle bisector. And this property is used a lot in reflection based questions. Srinivas, we are trying our best to do that also. Don't worry. Don't worry about it. Physics sir will take as many classes as possible for class 12 also. Don't think that because this series has started, other things will be stopped. We are there. We are trying our best. Okay. For 12th for JEE 2026, we'll study from the scratch. Don't worry. That's why coordinate geometry we have put first. Coordinate geometry, guys, is the gate or is the door towards calculus also. Literally, right now you might not be realizing it, but as you proceed step by step, you'll understand the way of thinking in calculus. For 2026, I'm asking beta. Srinivas, in 1 month, as many topics as he can, at least the importance and high weightage one, I'll ask him if he can take. Okay? Don't worry. Don't worry, beta. Don't worry. Okay? Right? This thing you understood. C by B, angle bisector, main importance or main property or main thing about it is that angle bisector will divide the opposite side in the same ratio of the sides containing it. If this is C by B, this will also be C by B. So here it will be C by B. Similarly, this is also angle bisector. This is also angle bisector. Okay. So here C by C, this C by C, this is C, this is also C. If you look in ABD, this triangle, if you look in ABD triangle, then C by C will be equal to, let's say this is some I and this is K, I by K, right? This point we are looking at. We are looking at this point. I'm just trying to let you think how to find, how to look towards this point. Okay. Let's say I call it, what are we finding? This is incenter, right? So incenter I. Now AB, first of all, first thing is that AB by, what did we say? AB by AC is equal to BD by DC. Great. Both are C by B, C by B. Similarly, one more thing we can say that this is the angle bisector for these two sides. This angle bisector is containing these two sides. So AB by BD will be equal to AI by ID. Okay. Why I am trying to do this? Because if we can find this ratio, then we'll be able to find this point. Before that, we'll have to find this point. That's another thing. Before that, we'll have to find this point. That is another thing. And coordinates are here. X1, Y1. Coordinates we can always mention. X2, Y2. X3, y3. Correct? So coordinates of D, what will be the coordinates of D? Sir, it is simple, cx3 plus bx2 divided by c plus b, comma, let me remove all this so that we have more space. Okay, this and y coordinate simply cy3 plus by2 divided by c plus b. Okay, these are the coordinates of D. Coordinates of D we have, if we have this ratio ai by id, then it will be much simpler, right? It will be much simpler. We'll just put it over here. We'll just put it over here in D. Yes or no? Okay. Now what do I need? I have AB, no problem. AB is C. I have BD also. Do I have BD? Do I have BD? I have BD, but it is giving me 1 only. I have BD, but it is giving me 1 only. C by C. AI by ID is also equal to 1 by 1. Kya? Can I say that? Can I say that? Can I say that? Just think. Try to think more. If you're watching the video also later on, what I'm trying to do, you try to do it once on your own. Take your time to think. That's what I want. I've given you the direction. Now take your time. How can we reach on I? Take your time. Take a minute. Take a minute, please. Achha, one mistake I hope you guys don't do. C by C, this is ratio, this is C ratio B, this is C, this is ratio. Okay, don't say that C by C, sir, it will become 1, sir, AI by ID will become 1. No, AI by ID will not become 1. How will it become 1? This is ratio, bhai. 1 ratio 2 is different. 1 ratio 2 is different over, it can be different over here, right? It can be 2 and 4, it can be 3 and 6. So 2 by 3 is not 1 by 1. Getting my point, no? I hope you understood what I am trying to say. This C, B and are not, these are not exact numbers. This is giving you a ratio. C by B can be 1 ratio 2. 1 ratio 2 it is dividing. If this is 2, this is 3, this is dividing in 2 ratio 3. 2 ratio 3 can be anything. 6 ratio 9 is also 2 ratio 3. 4 ratio 12. 4 ratio 6 is also 2 ratio 3. But that does not mean C by C will make it 1. Okay, getting my point? No, you'll have to find. How can we find? We know, see, whenever we have a ratio, suppose 5 apples are divided into 2 ratio 3. So 2 and 3, 2x plus 3x equal to 5 you will do. X equal to 1, 2 and 3. And then suppose 15 apples are divided into 2 ratio 3. Then 2x plus 3x will become equal to 15 apples are divided into 2 ratio 3. So what do you do? 2x plus 3x equal to 15, then you'll write 5x equal to 15, x is equal to 3, right? Then you'll say, acha, this is 6 and this is 9. 6 and 9, that is making 15. That's how you do. So here also you do the same thing. Cx, this Cx plus Bx is equal to what? A. Total is A, that we know, total we know. Acha, x will become equal to A by C plus B. X will become equal to A by C plus B. So Cx will be what? What will be Cx? Cx will be equal to Ca by B plus C. Cx, this part will be equal to Ca by B plus C. This part. Correct? Try to understand this, try to grasp this. Okay. What will be the length? Cx means this length. What is our Cx? Cx is this length. That means this is going to be equal to BD is going to be equal to Ca by B plus C. Nothing. We got exact length now. C is not the exact length. It is part of the ratio. That's it. Okay. Now look at this. AB by BD. AB by BD means AB is exact length. We have C. BD is exact length. We got Ca by B plus C. Okay. We have got into ratios, but try to understand. C upon Ca by B plus C. What do we get? We get, sir, B plus C by A. That is the ratio of AI by ID. Now you can write it over here. This will become, now you can write it over here. This will become B plus C. This will become A. Right? Now you can even find this point. So this point will become, now you'll just put it over here. This point, D is this. D is this. D you have. D point you have. Now B plus C into X coordinate. B plus C into X coordinate. What is the X coordinate? C x3 plus B x2 divided by C plus B. Right? Plus A into X coordinate of this one. Plus A x1 divided by what? A plus B plus C. This is how you get your answer. And coordinates. So coordinates of incenter I am writing over here. Finally you will get coordinates of incenter. Coordinates of incenter, how will you get? For this triangle, let's say x1, y1, x2, y2, x3, y3. Incenter, that means the point where all angle bisectors are meeting. This I will be nothing but ax1 plus by1 plus c ax1 plus bx2, this formula only, no? This, when you solve this, this will get cancelled. What will you get? Ax1 plus bx2 plus cx3 by a plus b plus c. Ax1 plus bx2 plus cx3 divided by a plus b plus c. This will be the x coordinate. Y coordinate will be a y1 plus b y2 plus c y3 divided by a plus b plus c. This is how we get incenter. Idea of angle bisector. This property of angle bisector is going to be very much needed. Proof you will be able to do. If you don't do also directly remember the formula, that's also fine. But this property is going to be useful. One more thing, one more special thing about angle bisector I would like to tell you, which will be needed in problems. That suppose angle bisector is there. Okay, this is the angle bisector. Okay, this is the angle bisector. Alright. Look at this like a reflection problem. Look at this in reflection problem, it will be very much useful. Angle of incidence, angle of reflection. Okay, angle of incidence, this is your that thing normal. Angle of incidence, angle of reflection. Every point on the angle bisector will have its image on the other side of the angle bisector. Every point on this side will have its image through the angle bisector on the other side. Right now just listen to it. Okay, just listen to it and note it down somewhere that every point on one side of the angle bisector will have its image on the other side. Very useful, very helpful. We'll see in the PYQs how we are going to use this property. Okay, very useful. Incenter also we found. How we found? That idea, that problem solving was important. That thing is important. Okay, not the formula. Formula though you can remember anyway. They are not going to ask you direct formula based question also. They'll give you some things from it and then you'll have to derive a part of this formula somewhere. That's the idea. Okay, incenter also done. What was next? Achha, these things we have done, right? Angle between two lines, where theta is the acute angle between two lines. Acute angle we are talking about. The other angle will be pi minus theta, that we'll be able to find. If lines are parallel, then m1 equal to m2. If they are perpendicular, m1, m2 equal to minus 1. Achha, if they are perpendicular and m1 is coming infinity, then m2 has to be 0. Then only they'll be perpendicular, right? Suppose in some case m1, one of the slope is coming 0 and it is given that slope of one line is coming out to be 0. Okay, so y equal to c basically. In that case, the line perpendicular to it will have its slope equal to infinity, right? Then only they'll be perpendicular, no? Right? So in this case, it won't apply. In this case, m1, m2 equal to minus 1 won't apply. Generally, in the general form, the slope will be minus a by b, coefficient of x upon coefficient of y, minus of that. These things are okay. Tan theta, relation between m1, m2, m2 minus m1 upon 1 plus m1, m2. This also we did. Acha, this thing now. Now, again, I'll come back to the problem. That, sir, one more point is there. Perpendicular bisector intersection. Orthocenter is there. Intersection of perpendicular bisectors. How will we approach towards that? For that, for finding the perpendicular bisectors intersection, what we are going to need is the length of perpendicular. Okay. And whenever we talk about, write it down somewhere, whenever we talk about perpendicular or from a point, what should come in our mind? First thing which should come in our mind is area. Area. Because area can be found in multiple ways. Second thing which should come in our mind, this is, I'm telling you, this is the way of thinking. If perpendicular is coming in the question, what should strike your mind? Area should strike your mind. One way, okay, let's break this problem into a smaller one. Right? Let's break this problem into a smaller one. That there is this line. There is this line ax plus by plus c equal to 0, and there is this point x1 comma y1. I want to know what is this distance. If I make a perpendicular from this point on this line, what is this distance? Whenever this type of thing comes in a difficult problem, advanced level problem, in mains, formula based approaches will be there, but in advanced level problem, if this thing comes and question wants you to think more, what do you think? What should come in your mind? Area is one thing which should come in your mind. What else? Area, why area? Because you can always connect it like this, find the area, and in area half base into altitude. Another way of finding the area is through determinants, right? So there are two ways. That's why area should come into your mind if you want to find the perpendicular. What else? Circle can come into your mind. Circle can also come into your mind. Sir, if I make a circle over here, then this will be bisected. Property of circle. Center, from center, if we sorry, my circle is very bad. Wait. This should come into your mind, and this should be the center. Circle can come into your mind, but mostly area will help. But sometimes maybe circle also I'm writing, or trigonometry should come into your mind. Most important is this area. Here also we'll try to approach towards this problem through area. Acha, how? Sir, okay, let's take this as x2, y2, and let's take this point as x3, y3. Okay, sir, now what? Now what? Now use the area concept. Just take a minute and use the area concept to find D. You know the formula, but still find D. You might know, but still try to find the distance. Try to find the perpendicular distance from this point, between this point and this line, using the area concept. I already told you what you're supposed to do. Take a minute. Just asking you, think what should come by area. If you want to find, what will you do? Sir, I can do one thing, that I can find this distance. I know how to find this distance formula, basic distance formula we know, right? x3 minus x2 whole square plus y3 minus y2 whole square under root of this. Okay, this is base. Altitude, I'll mark this point as something, and somehow I'll equate it to determinant form. What is the determinant form? x1, x2, x3, y1, y2, y3, 1, 1, 1. This is the determinant form. Correct? This is the determinant form. Half is also there. This is the determinant form. So you'll equate and you can do something about it. But here it will get more complicated. Let's generalize this. Right? But you got the idea, right? You got the idea what I'm trying to say. Whenever you're talking about perpendicular from a point, area should always be there in your mind. For a complex type of problem, area should always be there in your mind. Okay, ji. Now, let's say this triangle is somewhat like this. This is your line. AX plus BY plus C equal to 0. Okay. In this case, you'll be able to find very easily. Now, let's say here is a point x1 comma y1. Let's not generalize with this thing only, origin. Let's say x1 comma y1 is a point over here. Every line will be like this only. Somewhere it will be intersecting the axis. Somewhere it will be intersecting the axis for sure. Okay. Let's say it is intersect. Let's make this I just converted this diagram. x2 y2 and x3 y3 can be now plotted. Why? Because I know what will be this intercept. On this intercept, x will be equal to 0. Y will be equal to 0. So when I put y equal to 0, what will be x? Minus c by a. So minus c by a comma 0 I can write. Wait. If I put y equal to 0, x will be minus c by a, correct? If I put here x will be equal to here x will be equal to 0. So what will be y? Y will be minus c by b. So 0 comma minus c by b. These are the coordinates. Now the problem looks a bit easier. Now again, but I'll try to write the area. I'll try to look at the area, because my problem is finding this distance d. Now one way to write the area is, what is the distance? What is this base? Now let's say this is A, this is B, this is your C. So what is BC? What is BC? BC can you write? Minus C, BC we can write, no? Distance formula, x2 minus x1 whole square. So C square by A square plus y2 minus y1. So this will also be C square by B square. Okay, so it will become C square common, and A square plus B square divided by A square B square. Right, this will be your BC. So one way of writing it is half into BC, which is this, half into C square into A square plus B square divided by A square B square. Okay, half into base into altitude, which is D. Right, another way. What is the other way? If you have forgot, then just revise the determinant way of finding the area. Okay, just now I told you, area of triangle connecting x1 y1, x2 y2 and x3 y3 can also be written as half mod of determinant, and determinant also mod, because we are talking about area. x1 y1 1, x2 y2 2, x3 y3 and x2 y2 1, x3 y3 1, like this. This is the area. So this we'll compare it with this one, half into, now x1, what do we have? X1 we have x1 y1, the other two are 0 and minus c by b, and then minus c by b 0, 1 1 1, Arey, this is same as that. If you have in coordinate geometry also, if you don't remember the determinant formula in coordinate geometry class 10, you must have studied, no? Half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. That you remember? That same thing. If you open this, that same thing will come. If you open this, same thing will come. x1 into y2 minus y3 plus x2 into y3 minus y2 plus x3 into y1 minus y2. That thing only will come. This is nothing but this you must have studied. x1 into y2 minus y3 plus x2 into y3 minus y2 plus x3 into y1 minus y2. This I am sure that you have studied. In coordinate geometry, area of triangle connecting the three vertices x1, y1, x2, y2, x3, y3. This you remember. If you compare these two, what will you get? You will just get D equal to, okay, mod of ax1 plus by1 plus c divided by square root of a square plus b square. This is what you are going to get. Your D will come out to be this. This is your distance of a point from a line. Say in simple words, suppose there is a line given to you. Line is 4x plus 3y plus 1 equal to 0, right? And you want to find a distance, perpendicular distance of 1, 2 from this line. Just simply satisfy this point. 4 into 1 plus 3 into 2 plus 1 divided by square root of a is 4, b is 3. So 16 plus 9, 25, square root of 25. This will be your distance. Okay. So what do we get? 4 plus 6 plus 1 divided by 5. That means 11 by 5 units will be your perpendicular distance of 1, 2 from this line. That simple. But how did we reach this is important. How did we reach towards this is very, very important. Okay, point also, right? Area concept should come in your mind when you are talking about distance. Now, suppose two lines are parallel only. Suppose two lines are parallel. Sir, this line and this line are parallel. What is the distance between these two? Distance means perpendicular distance. Okay, let's say this is also D. Acha, if these two are parallel, shall I write it like this? AX. Do you mind if I write it like this? AX plus BY plus C equal to 0. If they are parallel, coefficients of X and Y will be same. This is AX plus BY plus this is C1. Let's say this is C2 equal to 0. Can I write this? Acha, leave the distance between two lines. Basically, what are we looking at? Distance of this point from this line. Distance of this point from this line. Let's say this point is x1, y1. What will be the distance? Sir, ax1 plus by1 plus c2 divided by square root of a square plus b square. Okay. Okay, can I say that? ax1, I'll satisfy this point in this line. This will be the distance D. Acha, over here ax1 plus by1, x1 and y1 are on this line also. So from this, can I say ax1 plus by1 plus c1 equal to 0 will be true because x1 comma y1 lies on this line. x1 comma y1 lies on this line. If it lies on this line, then saying this will be true. And in this case, ax1 plus by1 will be nothing but minus c1. So this distance D will come out to be nothing but c2 minus c1 mod, obviously. Right? Distance we are talking about, so mod divided by square root of a square plus b square. Distance between two parallel lines. Don't remember it as a formula. Remember it as a problem and solution of a problem. Okay. Now, these are the things which we just did are written over here. Special case, distance from origin. Distance from origin is simple to find as origin means 0, 0. So ax plus by will become 0. So c upon root a square plus b square. Simple. Exemplar problem is there. Same thing is written. Distance of a point from a line. Formula is written. All these notes you'll get. Distance between two parallel lines. This is D, this is C. We took C2 and C1. Here we have small d and small c. So d minus c upon square root of a square plus b square. Mod, don't forget mod. Sometimes problem directly will be given to you that distance between two parallel lines is equal to 3. In that case, if you are finding something, don't forget this mod, right? This will become equal to 3. Then when you'll open it, d minus c upon square root a square plus b square should be equal to plus or minus 3. Include both the cases. Don't forget the cases. This mistake you can do. Many students do. Sir, distance means 3 means only one condition. No. Strategic problem solving is very important for maths, guys. Don't make this mistake. Okay. Plus minus 3. Include both of them. Wherever mod is coming, no. Especially in these type of cases. Plus minus 3. Area problems also. Include both. If they might be finding you number of solutions, or they might be finding you for how many values of x, how many values of a variable this condition is true. Mod is there because of a reason. So include both plus minus 3. Okay. This is done. Now one more thing comes. Foot of perpendicular. Foot of perpendicular. Can somebody suggest me how will we find it? Foot of perpendicular. I'll suggest you the idea, you try it on your own. You have this line, you know the perpendicular line also. You can write the perpendicular line, no? Equation of perpendicular line. It will just become bx minus ay plus some e equal to 0. Perpendicular line formed. Intersect these 2 points, satisfy alpha comma beta, you'll get just this. How to remember this? That I'll tell you. How to remember this? That I'll tell you. Foot of perpendicular, that means I want this point. I don't want distance. I want this particular point. There is this line. There is a problem also given over here. X plus 2y minus 1 equal to 0. I want the coordinates of this point, foot of perpendicular, alpha comma beta. And this point is also given to me. Let's say 2 comma 3. How do you remember this? Alpha minus x1 divided by coefficient of x. Beta minus y1 divided by coefficient of y equal to minus of this point satisfied in this line divided by a square plus b square. Simple solving is there. Write the equation of this line, satisfy this point. Right? There are two ways of writing this equation also. We have 2-point form and you can compare and solve. This equation you'll write, right? This equation will become bx minus ay plus some e equal to 0, let's say. One more way of writing this equation is 2-point form. Write in that way. Compare both of them, you'll get exactly this. You'll get exactly this thing. Okay, try it once. How to remember alpha minus 2? I'll solve for this. Alpha minus 2 divided by coefficient of x1. Beta minus 3 divided by coefficient of y2 equal to minus of this point satisfied in this line. That means 2 plus 2 into 3, 6 minus 1. Divided by, here square root is not there. Okay. Divided by a square plus b square. So 1 plus 4. Now compare this with this. You'll find alpha. Compare this with this. You'll find beta. Simply alpha will come out to be 3 by 5. Beta will come out to be 1 by 5. Okay. That's how this thing also can be approached. This thing can be solved. Along with this, if you have this point, if you are able to find this point, breaking this into 1:1, reflection of a point through a line, image of a point or reflection of a point through a line, image of a point through a line. This thing is important over here. Okay, image of a point through a line. Also, same approach you'll have to find. Just one point you are finding, this point you'll find, and then you'll just use the section formula 1, 1 to find this point. This one you already have. This one you already have x suppose this is alpha comma beta. So Alpha comma beta, you already have alpha minus x1 upon a equal to beta minus y1 upon b equal to minus of ax1 plus by1 plus c divided by a square plus b square. This you already know. When you know this point, you'll use this point and use the section formula to find this point. Proving this will take time. You can do, but you know the approach. What difference is there? Difference is nothing. Over here, alpha dash beta dash. So alpha dash minus x1 divided by coefficient of x. Beta dash minus y1 divided by coefficient of y, which is b, equal to, just pay attention over here, in the entire formula, here instead of 1 instead of minus 1, minus 2 will come. And you can guess that or remember that by knowing that this is 1:1. Okay, two parts. One, this was one distance, this was for 1 point, this was for point which is one unit more far from that point, so minus 2, right? In case of image, minus 2 will come. Just remember that much. This is also one formula important, especially for advanced. Sometimes based on this formula, based on this thing, questions are asked. Mains, very rarely we have seen, yeah, but in mains definitely this thing can come, but in advanced probability is there. How do we approach? Simple, same thing only. Distance. What is the area of parallelogram? Area of parallelogram is base into height. Okay, base into height. So if you have this as base, this will become your height. You know how to find this. What will be this? This will be distance between this line and this line, right? That is C2 minus C1 upon square root of A square plus B square, M square, M1 square plus M1 square. Achha, same slopes will be there, na? Same slopes will be there because parallel lines are there. M1 square plus M1 square. I'm doing correct, no? And these two are parallel lines. Base into height. Solving these two lines will give you these 2 points. Solving these two lines will give you these 2 points. And multiplying it with height, when you'll solve something like this will come. And finally, you'll solve it into this. C2 minus C1. Just remember it like this. C2 minus C1 into D2 minus D1. Any two sides. You can take divided by M2 minus M1. Divided by M2 minus M1, and obviously the mod of it because we are talking about area. Remember this formula as it is. You can try deriving also, not a problem. Now you have the approaches how to think. Right now, because we have already prolonged the session for very long, there are more things remaining. So that's why I'm just giving you an idea. Now you know how to solve, how to approach towards the derivation also, right? Just use the distance between two lines and formula of parallelogram, base into height, right? You'll reach this here only. And here, moreover, you'll have to solve this line and this line. Solution of this line and this line will give you this point. Solution of this line and this line will give you this point. Distance formula, and then you'll have to approach like that. There can be other ways also, although there can be other ways also. What other ways can be there? That you find this perpendicular. Okay, this is not perpendicular. This is not perpendicular distance between these two lines. This is not perpendicular distance between these two lines. When we are talking about this length, this is not the perpendicular distance between these two lines. But yeah, perpendicular distance will be there, no? You know how to find this. Then use trigonometry to find this length and put it in this formula, right? Alpha angle will get cancelled, don't worry about it. Angle will get cancelled, everything will get cancelled. Finally, you will have this C2 minus C1 into D2 minus D1 upon M2 minus M1, right? If you derive this, you'll be able to easily remember this. Otherwise, also it's not a difficult to remember formula. There is no complication in that. Achha, now Anything else remaining? Let me just see the last things, what all we have done. Foot of perpendicular and all we have done, image we have done. Now, acha, one more thing is there. Condition of concurrency is there. Condition of concurrency is also one thing, I'll tell you. Although it comes in family of lines, but before family of lines. Now, family of lines is not there in your mains syllabus. Now, whatever is going to come is not going to be there in your main syllabus. Pathway to IT, how long the session will be? Hardly, I think 45 minutes, 40 minutes it should take, right? Not more than that, 40 minutes. Apart from this, locus problems are there, but locus problems we'll discuss while discussing PYQs only. है ना? We'll discuss while discussing PYQs only, because locus problems, there is no concept, just simple thing. Assume a point and whatever condition satisfies that point, you have to go for it. I'll explain you during the PYQ session also. Main concepts, main depth which you need for PYQ session, that all is there in this session. That all is there in this session itself. So watch this session. Okay. I was talking about concurrency. Concurrency means they'll tell you, check whether the three lines are concurrent or not, whether three lines are passing through the intersection, the same point, whether the three lines are passing through the same point or not. So there is a condition for that also. For example, let's say this is a1x plus b1y plus c1 equal to 0. This is some a2x plus b2y plus c2 equal to 0, and this is a3x plus b3y plus c3 equal to 0. Okay, how will you check the concurrency? Any suggestions? Only one way is there. Obviously, only one way is there. Solve any two. Suppose I solve these two. Suppose I solve this one and this one. Arey, what did I do? Oh, sorry. इसको लिख देते हैं a3x plus b3y plus c3 equal to 0. Suppose I solve this one and this one. अच्छा, you remember cross multiplication method was taught in class 9th or 10th maybe. Cross multiplication method. Everybody ignores that. I think they removed it from the syllabus also. Is it there in the syllabus now also? Cross multiplication methods to solve the linear equations, pair of linear equations. They removed it from the syllabus now. But see, now in class 11, you cannot leave anything. If you want to be really better at maths, you cannot leave anything. You have to have the knowledge of everything. Solving these x simply directly, if you remember cross multiplication, you will remember this. b2c1 minus b1c2 divided by a1b2 minus a2b1. Right? Y coordinate will be c1a2 minus c2a1 divided by a1b2 minus a2b1. From here you will get the intersection point of this one. This point is this one only. And when you will satisfy this in this line, right, when you will satisfy this in this line, a3 into b2 c1 minus b1 c2 divided by a1 b2 minus a2 b1 plus b3 into this one plus c3 equal to 0. When you will convert it into determinants, I'll just tell you the summary of it. When you will convert it into determinant, it will just give you like this: a1, a2, a3, b1, b2, b3, c1, c2, c3 equal to 0. If this comes equal to 0, that means your lines are concurrent. This is called as condition of concurrency. Condition of concurrency. For collinearity, section formula only is going to be used, don't worry about it. For concurrency, some specific questions are asked and you have to check the concurrency for what value of One thing will not be given. All the lines will be given. One coefficient or one constant will not be given. For what value of this will be the lines concurrent? So directly this you have to do. Directly this you have to do. Solve this determinant and put it equal to 0. You will get your answer directly. Okay. Please revise this session. Otherwise there will be no point of taking this session before the PYQ session. See, we could also take the PYQ sessions directly. That will also help you. But you know, many things which are needed there, if they are not taught in the correct way, then there is no point. Okay, that is the reason. So one more relation is there. Wait, do we need it or I don't think. Okay, I'll tell you, although we don't need it even in advance, but okay. Orthocenter, circumcenter and incenter. No, orthocenter, circumcenter and centroid. Okay, there is a relation between these three centers. Can somebody tell me in the chat? If you're there, please tell me in the chat if you know about it. Circumcenter, orthocenter and centroid. This is H, this is G, and let's call it C. These three are collinear. First of all, you should know that these three are collinear. Okay, know that these three are collinear points for sure. Okay, H, G and this C, these three are collinear points, and the ratio in which centroid divides the orthocenter and circumcenter is 2:1. Just remember this point. There will be collinear, and the ratio in which centroid divides the orthocenter and circumcenter, the ratio is 2:1. Very important point. You can mark it somewhere. And now let's go on to family of lines. Very easy thing. Nothing to worry about. Family of lines can be in two ways. Family of lines means all the lines which are following some similar property. There can be two ways to think of this. One way is, sir, all the lines which have the same slope, all the lines which have the same slope, this is very easy. Same slope belong to a family of line. All the lines which have the same slope belong to family of line. On this, there will be no question asked because it will be too easy for anything, right? In somewhere in books you might find, but in mains and advanced I have not seen. From this they are asking any question. If they are equating the slopes, if they are saying that the slope is same, then on parallel lines the question goes to the parallel line concept. But it is important to know that these lines are also called family of lines. Another way to think about family of lines is all the lines, suppose these two lines are there, L1 and L2, right? Now family means family cannot be of one person. Just remember it like this. Family cannot be of one person. At least two people you need. Husband, wife will make a family, no? Husband, wife, children, 2 children, 3 children, 4 children, grandparents, uncle, auntie, bua, nani, chachi, kaki, amma, appa, too many can be there. But at least 2 people you need, right? So, I'm sorry. Maybe I took it too far. Okay. At least 2 people you need. So 2 lines. Now, which lines will be called as the lines which are in family of these two lines? This is another way of thinking. Okay, all the lines which are passing through the intersection point, all these lines which will be passing through the intersection point of L1 and L2 will be called as the family of L1 and L2. And what does it conceptually mean? Understand carefully, listen to this part very carefully. What does it conceptually mean? It simply means that L1 and L2 are two lines. L1 and L2 are two lines. Let's say this is my AX1 plus B. A1x plus B1y plus C1 equal to 0. And this is my A2x plus B2y plus C2 equal to 0. Two lines. Now intersection point. If I can find the intersection point of these two lines very easily. When I'll find the intersection point, satisfy anywhere, I'll get this condition. If I find the intersection point, now you know how to find the intersection point, use cross multiplication or anything, and satisfy in any of these two lines, I'll get something like this. A1x plus B1y plus C1 plus some constant k, or generally they use lambda, right? A2x plus B2y plus C2. This will be equal to 0. This is what you'll get when you'll find the intersection point of these two lines and satisfy that intersection point in any of the lines. You'll get this. So in summary, what does it mean? That family of line L1 and L2, I'll write it, family of line L1 and L2 will be all lines which are of form L1 plus lambda L2 equal to 0. Okay. L1 plus lambda L2 equal to 0. Achha, lambda cannot be equal to 0 over here. Okay, lambda and L2, lambda, we don't consider that case, that lambda is equal to 0, otherwise there will be only one line, right? How can we talk about family of lines? If lambda equal to 0, that means L1 equal to 0, that means only one line, L2 is not there only, or concurrent lines are there, one line over the other, that case is there, so that's why we don't consider lambda equal to 0. Otherwise, just in simple words, any two lines L1 equal to 0 and L2 equal to 0, all the lines passing through their intersection points constitute the family of the lines. And how do we write it? Any line through intersection of L1 and L2 equal to 0 will be the member L1 and lambda L2. What form it will be like? For example, if I simply say that x plus 2y, okay, plus 3x minus 4y plus 9 equal to 0. I am getting this equation somehow. Or if I am able to form this, then what can I say? That any line which will be passing through the intersection of this line and this line will be considered in the family of these two lines. Okay, will be considered in the family of these two lines. That's something which I can conclude. I hope you can grasp it. Any voice issue kya? Let me check. Now, which type of questions? Very questions we'll discuss, but this one concept, for example, one simple question, that if A, B and C are in AP, suppose if A, B, C are in AP, then prove that there is a variable line. Then prove that there is a variable line AX plus BY plus C equal to 0. Always passes through a fixed point. That means if A, B and C are in AP, then any line which is of this point will always pass through a fixed point. How can we say that? Acha, if these are in AP, that means 2B is equal to A plus C. A plus C by 2 equal to B. So 2B equal to A plus C. That thing we can do. Now put it over here. AX plus A plus C by 2 plus C equal to 0 and Y. Right. Now AX minus plus A by 2 Y plus C by 2 Y plus C equal to 0. Take A common from here. A into X plus Y by 2 plus C common from here, Y by 2 plus 1 equal to 0. This will come. Right? Divided by A, what do we get? X plus Y by 2 plus C by A into Y by 2 plus 1 equal to 0. Can we do that? What does it look like? It is a family of lines which, this is a family of line. And what will be the intersection point of these two lines? X plus Y by 2 and Y by 2 plus 1. So Y by 2 plus 1 means Y equal to minus 2. Y equal to minus 2. And if Y is equal to minus 2, X will be equal to 1. Intersection point of these two lines. Which two lines? Y by 2 plus 1 equal to 0 and X plus Y by 2 equal to 0. Intersection will be this. That means any line in which A, B and C are in AP will definitely pass through 1, minus 2, which is a fixed point. This type of questions can be made from this particular thing. Or one more thing, one more question I'm looking at. Consider a family of straight lines. What other thing which they can ask you, they'll give you the lines. They'll give you a family of line. They'll give you two lines, or they'll give you an equation. I'll tell you, they'll give you an equation which looks like a family of lines. For example, X plus Y plus lambda into X plus 3Y, or let's say 2x minus y plus 1 equal to 0. This is a line. Or they'll tell you this is a family of lines. Now in this family there will be many lines which will pass through the intersection of this line and this line. Intersection of this line and this line, just solve. Intersection of this line and this line, x equal to minus y. 3 minus 1 by 3 and 1 by 3, right? Intersection will come, and now with this intersection they'll ask something related to another point. Find the distance of the intersection of find the distance of intersection of this point from another point, or maximize the distance, minimize the distance. All that you can do. Or perpendicular, or any line which is in this family of lines which is perpendicular to another line, or which has a perpendicular distance from another point. These type of questions they'll ask. For example, they can say that which line from the family of these lines, this is a question actually from IIT only, which line which passes through the intersection point of these two lines, or which line which belongs to the family of these lines will have the farthest distance from a given point. Farthest distance means perpendicular distance. Farthest distance means perpendicular distance, right? That's it. Or they'll ask you equation of that straight line. So that also you'll be able to form. Main idea is understanding the concept of family of lines. So this is it. You won't need anything more than that. Other things we'll see in the questions. Any line which passes through, acha, theek hai, this we have studied. For sure it passes through. See what is written, if equation of line is of the form x plus this and this, then for sure it passes through the intersection of these two lines. Main thing you have to remember, that any line which belongs to the family of this line passes through the intersection of this line and this line. That's it. Okay. Now angle bisector, a family of lines is also not there in your mains, and angle bisector is also not there in your mains. Angle bisector, when we were doing circumcenter, right? Circumcenter, what is circumcenter? Circumcenter is the center of the circle outscribed, circle passing through the vertices of the triangle. For that, what will you need? This distance, this distance, this distance are going to be equal, right? In this case also, and in incenter also, you could use the concept of angle bisector, right? The concept of angle bisector. Here also you can use, although we did not derive circumcenter and orthocenter you don't need to derive. Okay, one thing I forgot to tell, orthocenter when you are doing, right, any problem related to orthocenter, just solve it with perpendicularity. Suppose you want to find this point, intersection of the three altitudes. So simply you will have these points, write the equation using 2-point form, make the equation of this line, this perpendicular bisector. Okay, then write the equation of this line, make the equation of this perpendicular bisector, solve that to find the intersection point. No need to go for formula and all. Formula is very different and difficult. I'll tell you the formula for circumcenter also, although this is not used, but yeah, in vectors it will be used. So you can note it down for now. It is something like this: x1 sine 2a plus x2 sine 2b plus x3 sine 2c divided by sine 2a plus sine 2b plus sine 2c. This is how it will come. And similarly for y, right? So y1 sine 2a plus y2 sine 2b plus y3 sine 3b 2c divided by sine 2a plus sine 2b plus sine 2c. This will be for circumcenter. Orthocenter always solve using perpendicularity. You know the slope of this line, write the slope of this line and use the slope to write the equation of this line. You know the slope of this line, you will know, right? Information will be given, enough information will be enough. Use the slope of this line to find the slope of perpendicular line, write the equation of perpendicular line and solve these two lines to find the, only solve two perpendicular bisectors and you'll find the orthocenter. That approach only is suitable and is correct. Otherwise you'll get stuck or lost in this problem. Acha, one concept came, no? Over here. Acha, angle bisector of two lines. There can be two angle bisectors, right? There can be this angle bisector and there can be this angle bisector also. This angle is bisecting this one. Let's say this is alpha, this is alpha. Okay. And this angle bisector is bisecting this angle. So let's say this is beta, this is beta. Correct? What is written? 2 alpha plus 2 beta will definitely be equal to 180 degree. So alpha plus beta will always be equal to 90 degree. Remember this. This is important while solving the problems of angle bisector. 2 alpha plus 2 beta, complete line is going to be always 180 degree. Same thing will happen this side also. So only writing one side. And alpha plus beta, right? Alpha plus beta, two different angle bisectors if they are talking about, then use this. Alpha plus beta equal to 90 degree. Okay, use this. Otherwise, there are some simple specific formulas that I'll tell you. Equation of two angle bisectors, just note them down, or I'll also give you these notes, so don't worry about them. Angle bisector thing, if you can remember this, it is most suitable, right? It is most suitable. We'll also do these while solving the PYQ problems, but for now, write them down somewhere. A1x plus B1y plus C1 divided by A square plus B square equal to a2x plus b2y plus c2 divided by a square plus b square. Okay, or there can be two cases. Which angle bisector we are finding, that we don't know, right? Which angle bisector are we finding, that we don't know. Two lines will be there. Just divide the line by square of the coefficient of x and y, and same thing on the other side, same thing with the other side, same thing with the other line. When you'll equate these two, condition of angle bisector will come. Another one is same thing with a negative sign. So two angle bisectors are there. Suppose you have two lines, a1 x plus b1 y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Now they want you to write the equation of angle bisector of these two lines. There will be two angle bisectors, acute angle bisector, obtuse angle bisector. Which one are you finding? You don't know, right? So now how to check? Sometimes they might also say that which angle bisector is containing a given point. One point will be given to you and they'll ask you which angle bisector is containing this given point. So in that case also you'll have to be very careful. For example, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. This thing is given to you. What you have to do is this line, write this line divided by a1 square plus b1 square square root, equal to write this line divided by a1 square plus b1 square square root. One of the angle bisector you will find, right? One of the angle bisector you will find on solving this. Okay. From this, another angle bisector. If you want to find both, just put a negative sign in the same thing. You will find the other angle bisector also. Now, how do we categorize this? Let's understand this. Suppose they are asking you which one contains the alpha beta. Which angle bisector contains a point, given point alpha comma beta. If they ask you specifically this, that which of the angle bisector, out of two angle bisectors, which one is containing alpha comma beta? Okay. Acute angle bisector is this, let's say obtuse angle bisector is this, and they're asking you which of these contain the point alpha comma beta. Alpha comma beta can be somewhere over here or over here. Both are somewhere over here or over here, right? Which one is containing which one? So this you will check simply by using that condition which we learned earlier. Point with respect to line. So satisfy this point in both the lines. Satisfy this point in both the lines, take the product. If it is coming greater than 0, then required angle bisector is positive 1. This is positive, so required angle bisector will be, the required angle bisector which will contain alpha comma beta will be this one, will be obtained by this equation. If it is coming less than 0, then here also negative. Then the required angle bisector will be this one. Acha, acute obtuse you don't need to bother about. Which angle bisector is obtaining, that only will be asked. They won't ask you acute angle bisector or if both of them are relative to each other. So they'll ask you this thing only. Which angle bisector contains the given point? So if this product just satisfy alpha comma beta in both the lines, take the product comes out to be greater than 0, that means this is your required angle bisector. If product comes out to be less than 0, that means this is your required angle bisector. That's it. Okay. Sometimes special case, containing the origin. So containing the origin, x and y became 0, like point is 0 comma 0, so when you satisfy only c will remain. So just compare c1 c2 greater than 0 in same thing only, in this thing only. Here c1 c2 greater than 0, that means this angle bisector positive 1. If c1 c2 less than 0, that means this angle bisector with a negative sign. Simple thing. Okay. Acha, how to solve a question? This is also important. Before solving the problem of angle bisector, I'll explain this to you while solving problems also. But remember these two steps. Whenever you are solving a problem of angle bisector or equation of angle bisector, two steps are very, very important over here. Which two steps? Don't forget this. Okay, which two steps? First, make your C1 and C2 both positive. Whichever equation you are getting, in that if C1 and C2 are negative, then you cannot proceed ahead with the problem. Always make C1 and C2. Remember these two steps. Very important in solving the problems of advanced. C1 and C2, make both of them positive. Right? Now, if A1, A2 plus B1, B2 is less than 0, then origin lies in the acute angle, while If this is greater than 0, then origin lies in the obtuse angle. Specific type of problems that where in which, if they, most of the times they won't ask you respect to acute and obtuse. Only one type of problem will be asked. In that, these two steps only are important. In this problem, what they'll ask, that acute angle contains the origin or obtuse angle contains the origin. Okay, in that case, first make C1 and C2 positive, then just check this A1 A2 plus B1 B2. If that is less than 0, then your acute angle contains the origin. If A1 A2 plus B1 B2 is greater than 0, then obtuse angle contains the origin. That's it. Now, one more thing which I wanted to discuss with you all is the types of question. Okay, which all types can we have, or which all types of question can we expect? Just a minute. Just a minute. Wait, let me fix this problem. One problem is coming. Something is popping up over here. First, very basic, or first, if we discuss very basic thing which can be asked is on distance formula, right? You won't believe, but there are questions straight away on distance formula, right? So this you have to cover. Some small points which I want to cover, and you can also say revise. Okay, I'm just revising. Distance formula. Here, just remember ordinate and abscissa. Sometimes students get confused in this. Ordinate and abscissa. When they are asking about ordinate and abscissa, how can I make you remember? Ordinate means yo. O means yo. Yo means y. I don't know, I'm just making up. O, ordinate sounds like ordinate. Yo means y. So ordinate means y coordinate. Y coordinate, yo coordinate, y coordinate. Okay. Abscissa sounds like excissa. Abscissa and excissa are matching. So this means x coordinate. Don't get confused and make a wrong solution, because in options there will be an option which will be wrong. Okay, distance formula, this thing is there. Then they can ask you simple section formula. Remember m2x1 plus m1x2 divided by m1 plus m2. And same thing for m2x1 minus m1x2 upon m1 minus m2, both of them. External or internal bisection. Remember, special case is 1:1. Okay, then they can ask you based on slope. Simple slope based questions can be asked. Revise the slope part, right? Slope, remember slope is between 0 to 180 excluding 90. Slope tan theta cannot be 90 degree. Slope means tan theta cannot be 90 degree. Theta cannot be 90 degree, right? Theta cannot be 90 degree. On this particular thing they can ask you. Then collinearity. Many questions on collinearity are asked. Collinearity, right? Collinearity, concurrency and collinearity, two different things. Collinearity means, I'll explain over here. Wait. Concurrency, I'll write both. Concurrency means A1, A2, A3, B1, B2, B3 and C1, C2, C3. This is going to be equal to 0. This is concurrency. That means okay, sorry, somebody came up. Concurrency means, now collinearity means on same line. Concurrency means they are passing through the same point. Here means same point. Collinearity means on the same line. If they are on same line, that means area will be equal to 0. Area equal to 0. Area equal to 0 means simply x1, x2, x3, y1, y2, y3, 1, 1, 1. This is area equal to 0. Half you don't need to put because half will go that side and will become 0. So this is for collinearity. Okay. Remember these two things. Apart from collinearity, what else can they ask you? Position. Right? On position they can ask you. Position of point with respect to line. So here you remember A1x plus B1y plus C1 into A1x, A2x plus B2y plus C2. If this is greater than 0, that means points are on same side of the line. This means same side. If this is less than 0, that means opposite side. Small points, I'm just reminding you, or we can say revision we are doing. What else? Angle between the lines. Formula you know. Angle between the lines. Most of the times you'll get to use formula only over here. Angle between lines. Okay. Then the forms. One form to another. Right? Forms of line. Remember the forms of line. This thing, revise carefully. What else did we study? Normal form, all the forms. Okay, all the forms. Now, if we talk about the types specifically, there are many types we cannot say, but yeah, 12, 13 types we can consider. Few of them I'm telling you, rest of them we'll discuss in our PYQ session. One situation is very important situation. Many questions are asked from this situation. At least 10, 15. They'll give you simply 3 points, 1, 2, 3, 4 and 5, k. Okay, these 3 points, right? And they'll say area is equal to 8. Area is equal to 8. One mistake only students do. You can use any of the formula, the normal coordinate formula, you know, or determinant also you can use. 1, 3, 5, 4, 2, 4, k, 1, 1, 1. When you're solving this, okay, when you're solving this, area equal to 8, area equal to 8. In collinearity, we put it equal to 0 because there will be no area, collinear point, so area will be equal to 0. Here, if they are giving you area equal to 8 or 9 or something, if we are putting this equal to 8, then there will be 2 possible values of k for which area can be equal to 8. Why? Because when you open this determinant, this is entirely in mod. Right? This entire thing is in mod. When you open this mod, put plus minus 8. Don't forget that. Okay, put plus minus 8. This is one situation. Second thing which they can give you, rotation of line. Right? Suppose they'll give you, there is one line ax plus by plus c equal to 0, which passes through some alpha comma beta, some point which passes through some point, right? Okay, which passes through some point. This is some line which passes through alpha comma beta, and this is your line. Let's say this is L, this is your line L, and it is rotated some degrees around the point P. This line will be rotated to some degrees around point P. Let's say this is rotated by theta degrees. So in this case, what you need to do, you know that how much is your, and they'll ask you the equation of this line. This equation they'll ask you. So in this one, what can be your approach? Simple approach. You know this line, you know the angle of this line from x-axis because equation you know. So m you'll know, tan theta you'll know the angle of this line from x-axis. And now you're rotating this by theta degrees, clockwise, anti-clockwise direction mostly they'll give you. So slope of new line you'll be able to find. Add the slope, add this theta. You'll be able to find theta of this line. This is, let's say, x-axis. This is your x-axis. Then you'll know this angle alpha, which is slope of this line, and alpha plus theta will be slope of the new line. That only, and it will also pass through alpha comma beta. Slope point form you can use. Then intercepts based problems they can give you, right? Intercepts based problem, for example, a line is there which has a distance of 4, not intercept based, basically normal based, which I already showed you. I'll read a question. A straight line L is at a distance of 4 units from the origin, and it is making positive intercepts on the coordinate axis, and perpendicular from the origin to this line makes 60 degree of the angle, right? Suppose positive intercepts means positive intercepts will be in first quadrant, and they'll give you the origin's distance of this line from the origin. They might confuse you with the language, but remember simple points, normal form based questions, right? Normal form based questions they can give you. So here in this case, what you need to do, hi Blue Moon, hi Prasad. In this case, what you need to do, normal form, simple. You know this angle you'll know, or some information related to this angle. Sometimes they can say that this perpendicular is making an angle of 60 degree with another line. There is some more line which is, let's say, x plus y equal to 4, and this is making 60 degree with this line. So what you'll do, 60 degree with this line means what will you do? You'll use this tan theta equal to m2 minus m1 upon 1 plus m1 m2, and you'll put tan 60, right? Root 3 equal to this. One slope you'll know, obviously. One of the slope you'll know, this slope you know, another slope you can find. Slope of perpendicular you can find. Slope of perpendicular only you need, right? Slope of perpendicular only you need. This only is alpha. Slope of perpendicular only is alpha. And then you'll use simple your A cos alpha plus B sin alpha equal to P. This P also will be given to you, right? Acha, here just don't make one mistake. Here one mistake you can make over here. When you'll find this angle, again there is a determinant. So there can be two ways. There can be one more way. This distance can be from this side also, or this angle between this line and this line can be this one also. So consider both the cases, plus and minus both. Angle between this line and perpendicular is this angle also. Sorry, not this angle. This angle or this angle is also possible, na? So two cases will come. Two slopes will come. Remember that. Okay. Then rest we have discussed too many. Acha, one they can give you that line 1 is there, in which any form of equation they'll give you, and it passes through some P comma Q and makes an angle alpha with the line L1. This type of problems. One line they'll give you, another line is passing through some point P comma Q or some defined point will be given to you, and they'll give you it is making alpha angle with line L1. Again, angle between two lines you'll have to use. Okay. So practice the PYQs with all the concepts we learned. If you want one more session of some solving of questions, although we don't need, we'll be solving a lot of questions, but if you need, comment it in the comment box. I'll take solving, where we'll solve all the types of problems. Acha, one more type which they can use is that they'll say that there are two lines L1 and L2, parallel lines. They'll give you two parallel lines, and there is one line L3 which is passing through, which is intersecting L1 and L2 at some points, let's say A and some point B. Okay, at some point A and some point B, and they'll ask you something like this, or they'll say L3 is passing through P comma Q. L3 is passing through some point P comma Q, or let's just name one point P. Let's say this is some point P. It is passing through some point P. Okay. In this case, what you can do is use similarity. They'll ask you the distance between this distance, not perpendicular distance. They'll ask you what is AB. Right? They'll ask you what is AB. In advance, this type of problem is asked a lot of times. They'll simply ask you what is AB. So in this case, what you have to use is your similarity of triangles. Perpendicular from this point on both the lines will fall on the same line. Okay, now just use similarity over here. PA by PB equal to P this by this, and this you can always find. This point also you can find, these lengths also you can find. However you want to proceed, you can find these lengths also by using point and line distance formula, and then you'll be easily able to find AB. PA by AB equal to P, let's say this is Q and R, PQ by QR. You can find PQ and PR also, and then QR. So this is how you'll have to proceed. All right. Image and reflection based problems they can ask you. So one thing you can remember, that one thing I can tell you, if this is the incident ray and this is the reflected ray, this is your incident ray, this is your reflected ray, always know that when you extend the reflected ray, every point on incident ray will have its image on the reflected ray. Every point on the incident ray will have its image on the reflected ray. This much concept will solve every problem of yours. Every point on incident ray will have its image on the reflected ray through the reflecting line, right? Line on which it is reflecting. And every point on incident ray will have its image on the reflected ray through the normal. This is the normal, right? Through the normal. Every point here will have its image over here. I also told you angle bisector thing. One side will have this, these angles will be equal. So one side will have its image on the other side. And same thing applies over here. This angle, this is also angle bisector, you can say. Otherwise, just remember every point on incident ray will have its image on the reflected ray extended this direction also and this direction also. In this direction through normal you'll have to check. In this direction through the reflecting surface or reflecting line you'll have to check. Then locus based problems, and that's it. Locus based problems are there. Center based problems, all the formulas you know, all the methods I told you how to do in altitude case, in the other case, every case you know. Thank you YGT. Alright, so now please, the point of the entire session was solve the PYQs. Okay, go ahead, confidently solve the PYQs. Revise the session. If you want, watch on 2x once again, make the notes, okay, and try to solve the problems. It's not a problem if you are not able to solve, but it's a problem if you are not trying or attempting to solve. Trust me, if you want to get through JEE na, simple rule you have to keep, that I have to fight with math problems. You'll lose interest in math if you stop fighting with the problem. You know, math, the thinking of math is a strategic pattern, strategic way which you'll have to develop in yourself, and that will help you in physics and chemistry also. Problem solving, it's all about problem solving and patterns in math. Only few formulas I have asked you to remember. Rest you know how to derive, how to approach also, but it's better that you remember. Practice some problems so that these formulas will be on your tips. Straight lines is a vast chapter. It's a part of coordinate geometry, still very vast. It is very high weightage. If we are able to solve even 30% of the PYQs, no, rest I'll take care of. But if you are able to solve 30% of it with these concepts which we have learned, no, put it in the comment box. Let me know that you are able to. Let me know how did you like or not. So that's it. I'll take my leave. How much time we have taken? Oh my god, 6 7 8 9 4:30. Okay, koi baat nahi, no problem. Good session. I hope many things will be cleared. If you are watching the recording, then also try to do it with me. When you're doing next Thursday, we'll be doing PYQs. Before that, on many websites, year by year also you'll get PYQs. If you are able to find year by year, solve it year by year. 4 or 5 years if you are also able to solve, no, 3 years also able to solve, that is enough for me. But try. Don't just come in the next session without solving anything. Otherwise it will not be productive for you. Okay? Right? Take care. Thank you YTGT. Thank you. Love from Kerala. Thank you. Thank you. Alright. Love you too, bro. Thank you, dear. Thank you. Great. Take care, okay? I'll take my leave. Take some rest. Give some rest to your eyes and solve. Alright? Bye-bye. See you. Tomorrow is chemistry. Okay, attend that also. Then you'll have a little bit of gap. Next session, PYQ sessions will start from Wednesday. So you have enough time. We are not asking you to solve each and everything. Obviously, you cannot solve all the 10-15 years of PYQs, but as much as you can. Alright? Bye-bye. Take care. Thank you. Love you all.